Great, now you know all the core concepts of how to build a pipeline in GitLab CI/CD, and we have a structure of a CI/CD pipeline. In the script sections, or the main logic of the pipeline, we're just echoing some stuff. And of course, in real projects, we will be building and packaging an actual application written in some programming language and actually doing stuff like building an image, pushing and deploying that image to a deployment environment, and so on. So that's exactly what we're going to do in the next sections. So using the knowledge that we've gained in the previous sections, we're going to build a real-life deployment pipeline for our demo application. So let's see exactly what we will be configuring and how. So we will be using this Node.js application and building a complete real-life pipeline for it, which is going to have the following steps. First, we're going to run unit tests for the application, which are the simplest tests that basically just test the code itself. We're also going to run what's called static application security testing, which is basically scanning our code for any security issues. And we're going to learn all about different types of testing and how to do that when we get to that point. We're also going to build a Docker image from our application using the Docker file we have here. We're going to push that image to a Docker registry that GitLab actually provides. So we have a built-in Docker registry in GitLab for each project. So we're going to use that. And once we push that image, we're going to deploy it to a development server. So for that, we're going to create another simple EC2 instance on AWS, and we're going to use that as a development server to deploy and run the image that we built for our application. Once we have the image running on development server, we're going to see how to promote a new application version to staging or test environment and then to production environment. So we're going to build this whole automated CI/CD pipeline with all these steps for this Node.js application. But we're going to do that step by step. So in this chapter, we're going to start with the basic version of that pipeline. And this is going to include running unit tests, building and pushing the Docker image, and deploying that image to a development server. So that's going to be our first main structure. And as part of the real-life pipeline, we're also going to see how to increment and set the image version of our application dynamically in the pipeline instead of hard coding it in the code. And note that for the whole demo, we're going to use the free version of GitLab CI/CD to build this whole thing. So as a first step, let's actually see a little bit overview of our Node.js application and what's inside, and also what does this application do. So I'm going to clone it and run it locally and basically show you the UI of the application. So copy the clone URL. So in my GitLab CI/CD folder, I'm going to do git clone and the git URL of my project. And if we go inside, we have all the files here. So we have the code locally. Let's actually open this application code in Visual Studio Code to have a better visualization. If you don't have a Visual Studio Code, you can use any other editor, or you can simply download it. It's free and it works perfectly for any JavaScript application. So I'm going to open my Visual Studio Code. Let's close this and let's actually open this project. And make it a little bigger, and there you go. So now we have our application code in the editor. We have the GitLab CI YAML file, which we can edit here as well. We have our Docker file that defines how we build the Docker image of our application. And this is where the whole code is located. It is super simple. We have this index.html, which is basic CSS and just static content here. We have some images for nice visuals. We have the server.js, which is just starting the application in the background on port 3000 and also sending the images. And we have, for any application dependencies, we have package.json that defines them. So we're using Express for our application that basically starts the server. So these are our dependencies, super simple. We also have 3 tests for our application, and these are going to be our unit tests. So I basically added very, very simple logic that simply checks that we have an index HTML file and Docker file and git ignore file, and that's it. So if we accidentally removed any of those, it will fail. So that's basically the test. And the test is also using some libraries. And for that, we also have dependencies. We're using Jest and Jest JUnit dependencies. So if you don't know Node.js that much, don't worry about it. This is really, really simple logic. We don't have to go into detail or understand it. We want to be able to basically build it into a Docker image and then deploy it to the server. Right here, we have what's called scripts. So basically using npm commands, we can execute them. And we have 2 of them to run the application using npm start. That's what we're using in the Docker file, right? So the application has to start inside the container. So that's the start script that basically just runs the server.js file. And we have another script, which is test. So this will run all the tests defined here. And it is using this Jest. So usually you can write tests with different frameworks, right? So each programming language has multiple frameworks with which you can write tests. And for JavaScript, it's Jest. And we have these options here that we're passing to our Jest command that basically generates test reports for us, right? That's what these options are doing. It tells Jest, run the test and then give me a report of how the test ran. What was the result? How many failed? How many succeeded? Etc. And the reports can be generated in multiple different formats, and we're using a JUnit format. Again, we're going to see that in detail when we're actually running unit tests in our pipeline. For now, let's actually run the application locally to see the UI and execute the test locally to see how it looks like. So I'm going to open a terminal, and to run the application, just like we have defined it here in Docker file. So to start the application, we have to run npm install and npm start. That's it. However, note that we have to be in app folder to run those commands, because this is the folder where the package.json is and all the application files are. So we're gonna move to that folder. That's a very important step. Do not miss that. So in the app folder, where we have our package.json, server.js, tests, and so on, in this folder, we're gonna do npm install. This will check all the dependencies defined here and will just fetch them from internet, right? From the npm repository. So let's execute. And you see Node modules folder was created and those dependencies were installed. So we're good to go and to basically start the application. npm start, this will execute the script defined here, which is Node server.js. Let's do that. There you go. So we just started our application on port 3000 locally. So now if I go to browser and do localhost 3000, there you go. We see the UI of our application, and that's the index HTML that we have here. So we have this static HTML code with 2 images, and that's what we're seeing here. So that's how the application looks like. That's what we want to deploy on a development server. And now let's also see how to run tests. So let's stop the application, Control C. And let's run the tests, which is npm test command. Like this. And you see the command that we have defined here was run. And we have an output that all 3 of our tests passed. So everything is green. And since we're generating these JUnit format reports, test reports, when we run tests, we see that this JUnit.xml file was generated that basically includes the test results in machine readable way, right? So we have the test case, whatever we defined, and we have the results like no failures and so on. And that's it. And we can also exclude the JUnit.xml file from the repository because we don't want to check that in. And if I save, you see that it becomes gray. So it's being ignored by Git now. So .git ignore, if you don't know what it does, it basically gives you a way to exclude any generated files from being pushed to the remote repository, right? So each developer will have their own copy of Node modules and JUnit.xml. They don't have to be in the remote repository. the packaged log.json should be checked in. And that's why you see the color highlighting. These gray stuff are basically just ignored. You will have them available locally, but they will not be checked in to the remote. So let's actually add those changes and commit them. And push them to the remote. And note that for adding those changes, you have to go to the root directory again. So go out from the app folder. And once we push that, we should see the changes here. So that's our project. And we want to build this application and deploy it on an EC2 server using the GitLab CI/CD pipeline. So let's start with the first step, which is running unit tests. So those 3 tests basically that we have defined. And you can have hundreds of unit tests for your application. The more complex it is, obviously the more tests you will have. So we want to run them first. So let's go to the CI/CD pipeline and editor. And let's actually clean all this stuff up. So I'm going to remove the image. Let's leave the workflow. So this pipeline will only run either for main branch or for merge requests. For all the feature branches, it will be ignored. And we're gonna delete all of it. And we're building our pipeline from scratch. So first job will be to run unit tests. And we're gonna run these unit tests on our self-managed runner, which has a Docker executor. So let's provide the tags. So it's EC2, Docker, and remote. So we're going to run the unit tests inside a Docker container. The script for executing the unit tests will be npm test, just like we did locally, like this. However, you remember that before we were able to do npm test or npm start, we had to first change to app folder, because that's where we have the test, and that's where we have the package.json that has this test script. And we also had to do npm install first, because we need the dependencies for the tests so that they can run. So these 2 things need to run before we run the tests. And we can include that in before script, cd app, and npm install. And this will execute our tests. Now, since we're using npm commands, we also need to have those npm commands available inside our Docker container, right? So we're going to use an image that has npm command inside. So we're going to define image, node, and just go and grab the latest node image. I'm going to use this one, and that's it. So we're executing our unit tests using npm test command inside a Docker container with node image. So let's actually test this. Commit changes. We only have 1 job and 1 stage, so that's the only one which will get executed. And let's refresh, and there you go. So the job is green, which means the tests were executed successfully. Let's actually see the logs. So we have cd app npm install inside the node container, and this is where the tests were run. So we see in the logs 3 tests passed. We have no failed tests. So that's fine. However, we only see the test results inside logs of the job. So we have to go inside the job and see those logs. But we don't have an overview of the test executions inside the GitLab UI, right? And you see we have this test tab here, which is empty. And it says there are no test reports for this pipeline. Now, you remember that in our package.json, we actually have an option that generates reports for our tests in junit.xml format. However, we don't see any reports here. And also, in the list view of the pipelines, we have no artifacts for the test reports. So how do we use those test reports that we actually generated using Jest to show them in GitLab? Or basically, how do we make GitLab use those reports and visualize them for us in the UI. Going back to the editor, we can actually configure our job to use the unit test reports that Jest generates for us so that GitLab can display it for us. And it's actually very easy to configure. For that, we have an attribute called artifacts. Inside the artifacts, we have reports, and we have the format of reports. And there are a couple of formats, and we're going to use JUnit format and specify the generated JUnit file that Jest gives us. So junit.xml inside the app folder. So it's going to be app/junit.xml. So the way it works is that JUnit report will collect the JUnit reports from XML files. Those collected unit test reports will be uploaded to GitLab as an artifact. That's why we're using the artifacts attribute. And then GitLab will be able to actually visualize it for us and display it in its UI. Now, maybe interesting to note that JUnit was originally developed in Java. However, there are many third-party libraries to generate JUnit format test reports for other languages like JavaScript, Python, Ruby, and so on. And the Jest JUnit library is actually the one that lets us generate the JavaScript test reports in JUnit format. So that's just as a side note. And also note that the reports must be in XML format. Now we want those reports to be uploaded as artifacts, not only when the tests are green or they pass, but also when the test fails. And for that, we need to add a condition to say when, always. So even when tests fail, please upload those reports to see the failures of the tests. So with this configuration, we should see test reports in GitLab UI as well. So let's commit, view the pipeline, and if we refresh, we see that test execution is green. And here, instead of 0 tests, we have 3. And inside that, we have this visualization that actually came from the test reports. So we see a list of jobs that executed tests. And if we click inside, we see a list of tests for that job. It shows us the name of the test and the duration. And also in the list view of the pipelines, in the artifacts button here, it says artifacts. If I click here, we see we have an artifact that we can actually download. So this is going to be our junit.xml file. So we see this junit.xml file, which is zipped. So that's basically it, right? The same thing we saw in our JUnit file, basically that contains the test results. So this is the file that GitLab uses to generate this type of UI overview for your tests. Now, if you want to make your test reports, the downloadable test reports, browsable, so basically the folder structure and everything, we can add an additional attribute here called path, which is a list, and basically add our JUnit report there. And obviously this will make sense if you have multiple test reports that you want to kind of organize and not have them all in one place. So let's see the result of that one. Commit those changes. In addition to that path attribute, let's also make one more change, and let's fail one of the tests on purpose. So basically, in the server test.js, I'm simply gonna change this to be falsy. So the opposite, which should fail. Commit that. And let's see our pipeline. So this should actually fail one of the jobs, and we will see that in the test reports as well. And there you go. And here we have a failed job this time. Let's see the test reports. First of all, we have the success rate. So from 3 tests, 1 of them failed. If I click inside, also see the status here. And additionally, you have this failed jobs tab, if you notice, that also basically describes what exactly failed in the job. And in the list view of the pipelines, we should see that additional artifact that was generated using the path attribute. So that's the JUnit one that we downloaded before. Now let's actually see what's in that other artifact. And if I open that zipped folder, you see that it basically has a structure So you have the app folder, and inside that you have the junit.xml. So this one basically just gives you a more browsable, structured artifact of your reports. And as I said, this is more relevant when you have multiple different reports with the hierarchy and so on. So you can use that as well. And now let's see one final interesting thing in terms of how GitLab uses the test reports in this whole application development lifecycle. So let's say a developer is working on the code, they create a new branch. Let's say the developer wants to refactor some stuff, so let's call this refactor. And they're basically changing the code, cleaning it up and so on. And while cleaning up the code, they accidentally deleted the Docker file. So let's go here and delete this. And now that they are done, they want to create a merge request. So they didn't notice that the Docker file was deleted. Maybe while doing some merge, they unintentionally deleted this Docker file. So the test that validates whether Docker file exists will actually fail, right? So the developer now is done with the refactoring and they want to create a merge request. So let's create that. Now let's call this did refactoring. Let's leave everything as it is and let's create a merge request. So now another developer can actually review that merge request and see the status of it. Now let's wait for the pipeline to run. It is on pause currently, right? It is in progress. So let's wait for that to be done and see what happens with our failed test. And know that our pipeline logic is set to run when we make changes to the main branch or on merge requests. So that's why it automatically triggered a pipeline when we created a merge request. So let's wait for that pipeline to complete. And if I refresh, there you go. So first of all, we have these tabs here that says what we committed, the pipeline that ran for this merge request and its status, which is a failure, and the changes that we made, right? And in the overview, we have the pipeline status here, and we have something interesting right here. It says test summary contained 2 failed out of 3 total tests. And if I click on expand, I see a description of those failed tests. So these are the names of the tests that failed. And this one says that the test actually failed one time in main branch. So this is not related to the merge request. And this one is the new test failure that our merge request introduced. So this gives you actually a pretty nice summary or overview what tests are failing because of your merge request. And now another developer that is reviewing your merge request or you yourself can actually see what tests failed because as a result of your merge request, so you can go back and fix that. And you can also see the details of the test failure. If I click inside, it basically tells you exactly what happened and what the error was. So that's another interesting feature that GitLab gives you in terms of the test reports in your pipeline. And now, of course, you would fix those tests and so on. In our case, let's actually just close it. And that's it. So that's how you can run unit tests in your CI/CD pipeline for a Node.js application. So now we have one job that runs unit tests and let's say validates the code is correct. And once the unit tests are successful, we can build the application into a Docker image and then push that image to a Docker registry. So let's do those 2 steps next. First of all, let's go back to our tests. And let's fix that one test that we broke. So change it back to truly. We ignored the merge request, so we still have that Docker file. So now our test should be fine. And in our pipeline, we're gonna add 2 jobs, one for building an image and one for pushing that image to the registry. And as I said, GitLab actually offers a built-in Docker registry for every project, which is really good because you basically have everything in one place. And since GitLab actually wants to become the DevOps platform, so basically a platform where you build your complete workflows using the GitLab services and the best practices of DevOps, it gives you all these things out of the box or built into your project. So before we write those jobs, let's actually check out the Docker registry that GitLab gives us. So here we have all the stuff that GitLab provides us with, and one of them is packages and registries. So let's open this in a new tab. And as you see, under these packages and registries, we have 3 types of registries. We have the package registry, which is for general purpose artifacts like zip files or jar and WAR files and so on. So depending on the programming language and the tools that you're using, you can create those packages and push them here for your project, and they can be used maybe by other projects as dependencies or whatever. Then we have the container registry. This is the one we're interested in. So this is where we can push all the images that we built for our application. And currently it is empty. We haven't built any images and pushed them here. And right here you see the commands to log in to that registry, to build an image and push it here. So one thing to understand about Docker registries is that you have public Docker registries like Docker Hub, for example, where you can get all the images and access them without any credentials. Anybody can pull and download images from there. However, if you're a company and if you're building your own application images, obviously you don't want other people to have access to those, right? So you have private registries for that. And in this case, you have a private Docker registry for your application on the application level. And in order to access any images inside that registry or to push images to that registry, you need to authenticate first, right? So you have to do Docker login with some credentials, and now you can access, pull and push images from that registry. Also, another thing about registries and how to push images to a registry is that the destination or the registry location where you want to push that image is actually in the name of the image itself, right? So when we build and tag an image or give it a name, so to say, we include the registry address or location in the image name like this. So Docker knows to which registry it should push that image. So for every GitLab project, it will have its own registries. And the name of the registry, Docker registry for your application will be registry.gitlab.com, your GitLab username, and the name of your project, right? So it's my Node app CI/CD project. So that's the name of my image repository. And we also have a third type of registry that GitLab provides us with. This may change, they may add new ones in the future, but currently we have these 3. An infrastructure registry is basically a private registry for infrastructure as code packages. And in this case, specifically for Terraform. So you can write your own Terraform modules for infrastructure provisioning, which is related to this project or application, and you can host them here. Again, not relevant for this course, but just good to know that these are available. So going back to the Docker registry, these are the commands that we're gonna use in our pipeline. And one note about securing your container registry is that when you have a private project, only members of the project have access to that registry. So you can basically manage the permissions and access to your Docker registry based on the access for the project. And if you make the project public, then your container registry also becomes public. So as a first step, we're gonna build a Docker image for our application. So let's go ahead, write a job that will build our image. So we're gonna call this build image. And this will actually run on our managed GitLab runner, but this time with the shell executor. And remember, we have installed Docker on our GitLab runner, so we have Docker command available there. And then we have the script, which will build the Docker image. Now note that for building an image, you don't need to log into the registry. You can just go ahead and build and tag your image locally to whatever name you want. We're gonna need login to push an image. So I'm gonna copy this command and paste it here. And this will build a Docker image with this name, but we also want to add a version tag for our image. So we're gonna do colon and 1.0. So that's gonna be the version of our image. And then we have a dot, which is the location of the Docker file that will be used in order to build that image. And going back to our code, we have this Docker file in the root folder, so we don't have to change to app folder. It is in the root directory. So the dot current location of the root directory is fine. And inside the Docker file, we are basically using the base image, which is Node 16 Alpine. You can choose the latest one, whichever version you want. Then we're setting inside the container, we're setting the work directory to this location. We're copying the package.json and package.log.json, both of these from the app folder inside the working directory in the container. Then we're doing npm install. So the node modules get installed. We're copying the code into the image, exposing port 3000 and starting the application using npm start command. So really basic Docker file that basically copies everything from the project into the Docker image and starts the application using npm start command. So this Docker file will be used to build the image. And once we have that image, we can then execute push image job. Now we can do both in one job, but you can also split it. So in this case, I'm actually splitting and making it into two jobs. It doesn't really matter. And I'm also executing these on the same shell executor on our GitLab runner. And in push image, we're pushing the Docker image that we built to the repository. And again, don't forget the tag, the version tag, and there you go. However, as I said, before we push to a private registry, we need to authenticate using Docker logging. So I'm going to copy this logging command and we're going to do a before script which does Docker login, and that's our logic. Now let's introduce the stages again, because now all these three will run in parallel, which we don't want. So instead we're going to define stages here. So we're going to have a test stage and build stage. So let's add those stages here. Build image in the build stage and push image also in the build stage. However, we want the push image to wait until the build image job gets done, because we can't push an image that we haven't built yet. So these two should not run in parallel. And that's why we're gonna do needs and build image. There you go. Now there's one more thing that we need to do here on the Docker logging command. So whenever we're logging into a private Docker registry, in this case, GitLab's registry, we need to provide username and password credentials, which is logical because we need to authenticate ourselves. So where do we get credentials for our private registry? Because we don't have that on the commands here. You actually have multiple ways to authenticate. One of them is username and password. Another one is personal access token. In our case, we're going to use the easiest way, which is username and password. So where do we get those username and password for our registry? Where do we see those? Well, another cool thing from GitLab is that in a CI/CD pipeline, GitLab actually provides temporary credentials, username and password, for our container registry through environment variables. So we actually have the username and password for our private registry available inside the CI/CD pipeline using those predefined GitLab CI/CD environment variables. And if you remember, we have this predefined variables list where we can see different values that GitLab makes available within the pipeline, and the registry user and password are basically on that list as well. And in the description, you see that this is a username to push containers to the project's container registry, and you have a corresponding password. And this is a really good concept in terms of security, the way GitLab does it, because the way it works is that GitLab will generate those two and make them available only for that specific pipeline execution or the job execution. You see that here as well is valid only as long as the job is running. So even if the password gets leaked, it cannot be used again, right? So we're going to use those two variables as credentials in our Docker login command. So in Docker login, we have those options, -u for username. And this is going to be registry user. Remember, we reference the environment variables using $sign. And then we have the password, which is registry password. There you go. And with that logic, we can now execute our pipeline, and this should build an image and push it to our project's container registry. So let's commit the changes and see what happens. So our pipeline executed and all the jobs are green. You can check the logs to see what exactly happened. Let's see the push image logs, for example. So we have the Docker login command, Docker push command, and all the layers of the image have been pushed. Now, if we go to the registries and container registry, instead of an empty list, we should see one image that was pushed. And if I click inside, we have this version or tag 1.0. So this is our image. And if you want to pull that image, you can grab the full complete name of the image, including the tag, using this button here. If I click inside, this is basically the whole image name. So we have the registry, which is GitLab's registry, my username, the project name, and the version tag. Awesome. Now let's do some optimization to our pipeline. Let's go back to the editor. And right here we see that we're using the image name in two different places with the image tag, and it's hard-coded. And we also have the registry name, which is also hard-coded. And we don't want those hard-coded values. Instead, we want to dynamically get the name of the image repository and reference it here. Well, if we go back to those predefined variables list, we have two other variables for the registry. One of them is the CI registry itself, which is actually this value. So the general address of the GitLab registry. So we can reference this as a variable. And the second variable we have is the image repository name. So this is actually the value, the complete value of this, right? So the GitLab registry URL plus your GitLab username and project's name. And we can use that variable to reference the value. So we don't have to hard code it. Do the same here. And just to make sure, let's actually print out the values of those variables. Docker registry URL is let's also print out the registry user that gets injected and Docker image repository. And let's reference it like this. So let's execute our pipeline again. So everything is still green, and let's go to push image logs and check those values that we echoed. So we have Docker registry URL. This is the value that we're referencing with this environment variable. Then we have the registry user, which is GitLab CI token. So that's the username for the repository, and that's our image repository that we had hard-coded before. So all these values are injected by GitLab into our pipeline so we can reference them using the environment variables so we don't have to repeat them or hard-code them in our pipeline code, which is really great. Now, there's one more thing to understand in terms of the image hierarchy and how images are actually pushed to the repository. So right now in the registry, we have this URL that has the project name, and then we see something like slash and root image after that. So what is that root image? Or why do we have a root image in the URL? Well, this means that in our container registry, we can have multiple image repositories. And for each image repository, we can have multiple tags or versions. For example, so we may have a project that builds multiple applications, like a microservices applications, for example. And each microservice application will have its own image repository name. So we may have mynode app CI/CD project / payment service, or / user authentication, or / shopping cart, and so on. So instead of having everything in root image, which is the main bucket, so to say, or main space for all the image tags, we can have multiple image repositories, and each one can have its own tags. So root image is the global level where all the image tags will be pushed. However, as we saw before, if I copy this URL, it will not contain the root image, obviously, in the URL. It will just contain the name of the project, and then we're going to have a tag like this. So now let's say we actually want to give our image a hierarchy and give it some microservice specific name. So instead of the project name, we want to do something like microservice payment, for example. So we want this to be our full image name, and this is going to be the tag. How can we do that? Super easy, actually. Let's go back to our pipeline. And right here, we're simply going to append whatever we want, right? So I'm going to copy this. So we're going to do microservice payment. So we're building this image here, and we are going to then push that same image in Docker push. So let's see what happens now. Let's commit those changes. All right, so our pipeline ran. Let's go to container registry and let's check our image. So you see that a new URL was generated, or new image repository was added with a name that we defined instead of root image. And inside that we have this one tag. And again, if I copy this and paste in here, that's now the full name of our image. And now we could even parameterize the name of the microservice and pass it as a variable reference, for example, instead of hard coding it here, and create and push to a different image registry based on which microservice we're building. So let's say this is a microservice placeholder for microservice, like this. And let's do the same here, instead of the payment. Now I'm going to commit the changes, and let's actually, which will trigger the pipeline, but let's actually cancel the pipeline because we have to define the value of that microservice variable, right? So the pipeline is canceled. And we're going to trigger run pipeline manually. So if I click on this, it will show me that it's building a branch main. And here we can actually pass any variables that we want to our pipeline. So I can do microservice. So that's the variable that we defined in the pipeline, and I can set it to, let's say this is shopping cart. So we're passing this environment variable with shopping cart value, and let's run. And that's actually another way to pass in variables in a flexible way to your pipeline as an alternative to defining them globally here in the settings, like we did before. So going back to the pipelines, it is in progress. So let's wait for that to finish. And let's check the push image logs. And this is a new image repository with shopping cart at the end. So in the container registry, now we should see another image repository with shopping carts in the name. So that's how you can use your container registry for one project to build multiple images with different names, each one having its own tags. And let's do one final optimization to our code, because now we have this a little bit more complex image name and we're repeating it in two different places. Could be that we change something later and we forget to adjust it. So what we can do is we can take this whole image repository name and we can put it into a variable. So right here, let's define variables. And let's do image name, which we put together using those values. And let's also have image tag defined here. And it's going to be 1.0. And now we can reference those variables in our pipeline like this. Image tag. And there you go. And we don't need those echo commands. And let's actually push another tag so we see a second tag for the image. And we would need to pass that microservice value again to our pipeline. So let's do that. Let's actually cancel this one. Let's do shopping cart again. And let's see. So obviously triggering the pipeline manually and passing the variable is not convenient when you want to trigger them automatically, but we're just doing it for this example. And for the last time, let's check the container registry. And in the shopping cart image repository, we now have two tags, 1.0 and 1.1. So that's how you work with container registry in GitLab and how you push Docker images from the CI/CD pipeline to your project's container registry. At this point, we have a pipeline that runs unit tests. It builds an image and pushes that image to GitLab's Docker repository. And once we have that image available in the Docker registry, we can actually deploy it to a development server. So that's what we're going to do in this video. First of all, let's clean up our pipeline and let's actually remove this part because we don't have a microservices application. It's just one application. So let's just leave the name at the simple, say, registry name. Let's still keep the variables, image name and image tag, to make it easier to read and maintain and maybe update it later. And right here, let's add another job called deploy to dev. So that's going to be our next job. So what do we need in order to deploy our Docker image that we build and push here to a development server? Well, first we need a development server, right? Right now we have a GitLab runner on our EC2 instance. And let's actually tag our GitLab runner instance. And now let's create another EC2 instance, which is going to be our deployment server for development environment. So let's do launch instance. Let's choose Ubuntu server. We'll choose all the defaults, review and launch. And we're going to create a new key pair for this one. Well, let's call this dev server. Dev server key. I'm going to download this key pair because we need the private key available to be able to SSH into it. And let's launch the instance. So now we have a second instance, which is going to be the dev server. And let's actually give the name as well. So it's going to be dev server. There you go. Now on the dev server, when we deploy the Docker image and run it as a container, we need to have Docker available, right? Because we need to be able to run Docker on it. So what we're going to do is we're going to SSH into our dev server and we're going to install Docker on it. So going back to our terminal, we have this dev server key, which we can use to SSH into the dev server. But as you remember, we have to secure or restrict access to that key first. So let's do that. Change mod. Dev server. Let's limit the access permissions. And now we can SSH to our instance using that private key. And the username is going to be Ubuntu. And let's grab the public IP address. Yes. And we're inside our dev server. Now if we do Docker, you see, we get the installation command. Let's copy that. Let's first actually do sudo update, sudo apt update. There you go. Now let's install Docker. Great, so we have Docker installed. However, we cannot do Docker PS yet because we need to give our Ubuntu user the permission, which is permission to execute Docker, which we do by adding the Ubuntu user to Docker group. And we do that using sudo usermod command, add to the group called Docker, user called Ubuntu. And if we log out and log in again, Ubuntu user should be able to execute Docker commands. Awesome. That's all we need on the development server in order to be able to pull the image from our GitLab private repository and then run that image as a Docker container. So let's exit from here. Our job is done. And go back to our GitLab configuration. So we have the development server. It is ready and waiting for GitLab to deploy Docker application. But now the question is, how do we connect from GitLab pipeline to the dev server instance? The way we did it locally is we basically SSH'd into it using the private key, the name of the user, which is Ubuntu, and the public IP address, right? So we need this information so that GitLab can SSH into the dev server, just like we did locally, which means we need to provide GitLab the private key that we have available. So let's go ahead and do that. How do we provide GitLab a private key of a server? Pretty easy, actually. We go to settings of the CI/CD, and in the variable section, we're going to create a secret variable, so to say. So let's do add variable, and let's call this SSH private key. And the value will be the contents of the SSH private key file. So you can basically print out the contents like this, copy the whole thing until the percentage character, we don't need that one. So copy the whole thing and paste it in here. We're going to leave the protect variable checked. And here's one interesting thing. So protected variable means that it's only exposed to protected branches or protected tags, like the default main branch, for example, and not the feature branches. And we also have another check for mask variable. And this is actually something that you should check for any secret data, like a private key in our case. And the way it works is that it lets you use the variable in job scripts without the risk of exposing the value of the variable. So if someone tries to output it in the job log with a command like echo the variable name as a reference, the job log will only show the echo masked output, which is something we want for secret values. However, there is a limitation in GitLab when it comes to the private keys. And it means that we cannot mask variables with these values. And that has to do with the fact that mask variable has some strict rules about what type of content you can mask. And it is kind of a known issue or known limitation of GitLab. We can't really work around that. So we're gonna have to leave this unmasked. So I would say there is a room for improvement, and maybe this is gonna be fixed or improved in the future, but right now we cannot actually mask it. However, just note that whenever we're using secret values, so if this was a password or a token, we would actually mask that. So now, because of the limitation, we're gonna leave it unmasked. And finally, we're gonna change the type of our value to a file, because we want our private key as a file, so that we can pass it like this. And let's create our variable. So now we have that private key available for GitLab in the pipeline, and we can use that to SSH into the dev server. So going back to our pipeline, let's actually write the script that will SSH into the dev server, like we did locally, then does docker login in order to be able to push the image from the GitLab's private repository and then run the image as a Docker container. So let's do all of that. So deploy to dev, let's add a new stage, deploy, right here. So we're introducing a deploy stage, and deploy to dev will be executed there. Let's also execute it on our GitLab runner with shell executor, and the script will be the SSH command. And in our SSH command, we're gonna reference that private key. And as we learned, for a file type, when the runner makes this variable available in the environment where the job is running, it will actually create a temporary file and write the contents of this variable to that temporary file and store the path to that file's location as a value. And we can reference that file path using this variable. So that will basically reference our private key file, the temporary key file. Then we have our Ubuntu user and the public IP address. And again, if we don't want to hard code it, we can reference it as a variable. Let's call it dev server IP or host. And dev server host will have this value. Again, it's nicer to have all the variables in one place so you can change the values if you need to and just reference them throughout your pipeline logic. So we have the private key, we have the user, we have the IP address, and one thing we need to add as well is disabling the strict host key checking. So this basically refers to this prompt right here. Whenever we connect to a server for the first time, we get this prompt that says whether we want to confirm the authenticity of the host on our side. And in our case, we have to type in yes and so on. But since our pipeline is running in non-interactive mode, so we're not going to be entering some values there, we want to disable this check and just say skip that. So that's what we're going to do here, and this is going to be strict host key checking equals no. So that will take care of it. And with this command, we're going to be SSHing into the dev server. And once we SSH into the dev server, obviously we want to execute the Docker commands, right? How we do that? Also very simple. We're going to pass those commands as parameters to our SSH command. And we're going to put them within the quotes like this. So first, we're going to do the Docker login on that host, and we can actually reference those same variables that we have here. Super easy. So again, note, this gets executed inside the GitLab runner, and this gets executed on the dev server because we need to pull the image from the private repository, so we have to authenticate. And since we are executing them as shell commands, we're going to do end here so that we can write the next command, which is going to be docker run. So once we authenticate it with the private registry, we can now pull the image and run it on the server. So let's run it in the background in a detached mode. That's what -d stands for. We also need to expose the port. So we're going to bind port 3000 on the host to port 3000 in the container. Because if you remember, our app starts at port 3000 and we need the image in this registry, right? Which we can reference like this. So it paid out to parameterize all those values because we're using them in a lot of places. And it's good that we're not hard coding them. So that's basically how we're going to deploy our Docker image to dev server. Pretty easy. We're SSHing into it the same way as we did locally. We're executing docker login and docker run commands, and that's it. So let's execute our pipeline and see what happens. And we see that our pipeline actually failed. So let's see what the issue is here. In deploy stage, in logs, we see that the key is to open. So we have to limit the permissions to the key just like we did locally, right? So for that key, we basically executed this command. So we are getting the same warning here. So let's go ahead and fix that. And the way we can do that is we can add a before script here that basically executes the same chmod command for the temporary file, like this. And let's commit the changes again. And our pipeline is green, so the deploy build was successful. Let's check the logs again. And as you see, Docker login was successful and we were able to pull an image from our GitLab repository to that dev server to run it as a container. So now, if we log in to the dev server and do docker ps, we should actually see our container running. This is the image with the tag 1.1, because that's what we specified here, and it is available on port 3000. So now let's actually access this application from the browser. And for that, we're going to go to our dev server instance. First, we're going to make sure that the security group of that instance allows access on port 3000. So let's go to security, security group, edit inbound rules. And we're going to add a rule that will allow access on port 3000 from any source. And that's it. Let's go back to the instance. Let's copy either the public IP address or the public DNS. So let's take the public DNS, type it in the browser, port 3000, and this should display us the application, which is the same application as we have here. So we have built and deployed our image successfully on an EC2 server using our GitLab CI/CD pipeline. Now, in order to access the application, we had to go to the AWS UI, we had to get the DNS endpoint of the application. We also need to know which port it's running on, etc. And then we can type it in the browser. Now, let's say we don't want to search for this information every time we build an application. Instead, we wanted this logic to be inside the pipeline so that whenever we execute it and the application gets deployed, we have an overview somewhere where we can just click on a link and it takes us to the deployment endpoint. Can we do that in GitLab? We can actually, using a feature from GitLab called environment. So as I mentioned a couple of times already, GitLab strives to be the DevOps platform. So they want to integrate and offer all the features that are part of the CI/CD pipeline, or basically the whole application lifecycle, from the development, which is hosting your code in a repository, to all the Git workflows, etc., as well as all the features and tools for building the application, using all these types of registries, but also the final deployment phase, right? And for deployment management in GitLab, we actually have this deployments section with all these things that are related to deployments. And when we deploy our applications, of course, we want to secure it and want to monitor it to make sure that everything is running correctly and it has security and monitoring also integrated inside. So GitLab basically wants to build a platform where you have all this out of the box. So going back to our deployments and environments, let's actually click inside the environments. And right now you see that we don't have any environments or any endpoints of deployments for our applications. So let's actually configure our CI/CD pipeline to add a deployment environment. In GitLab UI, right here, we're going to have an overview of what we deployed to which environment and what is the endpoint of the deployment. How do we do that? It's also pretty easy. In the deploy job, we're going to add an attribute called environment. And environment has a couple of parameters. One is the name, so we can give it any name that we want. Let's call it development. So that's a dev environment. And it has the endpoint. So for example, if you have a proper domain configured for the application, this could be dev.myapp.com or something like this, a subdomain, whatever. And then for staging, you may have something like this and so on, right? So in our case, we have this public DNS and the port 3000 as an endpoint. So we can use that as a URL. And this is going to be HTTP. And there you go. Now, in our case, we can access the application on dev server using either public IP address or the public DNS name, right? So basically, we could reuse the value of dev server host as a URL as well, but in practice, it's not always the same, right? So SSHing into a server may have a different endpoint, and the application itself will have its own endpoint. So these two can be different. So in this case, let's differentiate them and let's use the public DNS as the URL. And again, not too hard coded. I'm going to reference it as a variable and let's call it dev endpoint. And right here, we're going to paste the value. And note that when this pipeline runs, GitLab will see that we have environment attribute defined here. So it will see that there is no environment with this name. So it will create one on the first run. And on the successive runs, it will basically know which environment we are deploying to. So now GitLab will know that this deployment basically applies to the environment called development. Let's commit the changes. So the commit will trigger a pipeline. And in order for the deploy to work, let's actually stop the running Docker container. Otherwise, this build will fail. So let's do Docker stop container ID. Otherwise, it will complain, obviously, that port 3000 is already in use. So it will not be able to run that Docker container. So now let's wait for the pipeline execution. So our pipeline has passed. The deployment was successful. And now let's go to deployments and environments. And as you see, we have a new environment here, which is called development. That's what we called it. And if I expand it, you see the status, the last deployment to that environment, which was 5 minutes ago, from which commit it was made, and so on. So this actually gives you a pretty nice overview of what commit or which state of your code is deployed to which environment. And the open link here will basically take you directly to that URL that we had to put together before and gives you a shortcut access to that environment. So this is additional nice feature of GitLab. And of course, when you have one environment, it's obviously easier to manage. But when you have multiple environments for multiple applications, this can be actually really helpful for knowing exactly which commit is deployed where, what is the state of the deployment, and when was it deployed last. And you can show even some more additional details, like which branch is deployed, from which job, as well as which GitLab user or team member basically triggered that deployment. And again, you have direct links to all of those, like going directly to the logs of that build. So in the previous video, we have added a deployment step to our pipeline, but our deployment is pretty primitive actually. We're just running docker run command and starting one container, and that's it. And now if I actually changed the version, and let's say we wanted to build a new image version and deploy that using the pipeline, let's see what happens. So the pipeline failed, or the deploy job failed, because we already have a container running on port 3000 on the host, so a new one cannot be run. So docker run command only works the first time when the container isn't running yet, and after that it will fail. So that's one problem that we have. Another problem or another issue would be if we actually wanted to deploy some other containers for our application. For example, if we needed a database for our Node.js application, or maybe we have an authentication service and some other additional stuff that our application needs, all of which should be run as Docker containers. So how do we run multiple Docker containers in the build without repeating this docker run command? And for this type of cases, we have Docker Compose, right? So Docker Compose basically lets us define a configuration of all the containers that we want to run as a list. And for each container, we can configure the ports that we want to open. Maybe we want to set some environment variables for those containers, etc. And we can define all of that in a Docker Compose.yaml file in a YAML format, just like our pipeline code. And we can just start everything defined in the Docker Compose using one Docker Compose command. So let's do that for our application. And let's create a Docker Compose.yaml file where we configure how our application's container should be run and deploy it using Docker Compose command. So we're going to make a change in the pipeline script as well as create a new Docker Compose file. So those are two changes that we want to commit as one. So it's not just a change to a pipeline. So what I'm going to do is I'm going to go to the files, and I'm going to actually switch to a web IDE stage. So that's basically having your code editor, but in a browser on GitLab platform. And that's actually another cool thing that GitLab offers. You can have an online code editor for your project. So this is the standard view of your application, and this is a web editor view. So now in this web editor, I can create new file, for example, and let's call it Docker Compose .yaml. And writing Docker Compose YAML file is super simple. We basically have a list of services, which are our images or applications that we want to deploy. We can give each service a name that we want. So let's call the first one app. Very simple. It's just going to be app. Then for that app, we have image, because Docker Compose needs to know which image are we using to deploy the container. And if we go to container registry, so this is the image that we want to deploy. So I'm just going to copy that, paste it in here, and we need to configure the ports, right? 3000 on host, 3000 in the container. Now, as I said, you can add other configuration stuff here. You can add environment variables, volumes, or whatever. We have just a simple use case. So this is exactly the same as what we're doing in our pipeline, right? So this command is basically corresponding to this configuration. Let's actually fix the indentations here, like this, and there you go. And as you see, as I opened a new file, it opened in a new tab. So we can actually work with multiple files at the same time using this web IDE. Right, so Docker Compose file is ready. One more thing we need to add here is fixate the version of Docker Compose. So I'm gonna use 3.3. You can check whatever the latest Docker Compose version is and use that one. And now that we have this Docker Compose file available in our project, let's use it to start the container instead of the docker run command. So we're going to remove the docker command and do docker compose, and then the docker compose file that we want to execute, which basically will start any containers or services defined in this docker compose file. And finally, we want to run it as detached, so in the background, just like docker run command. So that's it. Now, if we run this pipeline multiple times, again, we will have containers that are already running that we would need to stop first. And we can do that easily using docker compose. We can just say docker compose.yaml down. So down will basically do the opposite. It will go through the docker compose file. It will find all the services defined here with the images, and it will stop all the containers that are running from this definition, and then start all the containers with that definition. And this will not fail even if there is no container running from the docker compose file. So we are safe to run it as many times as we want. So whether it's the first time executing it or not. Now there are two more things we need to do to make this work. The first one is that we're executing docker compose file on the dev server, right? So just like we installed Docker and made it available there so that we can execute Docker commands, like docker login in this case, we need to also install Docker Compose on our dev server to be able to run Docker Compose files, right? So these commands will execute inside the dev server, not in GitLab runner. This is the command that will execute on the GitLab runner. So in order to do that, we're gonna SSH on our dev server and then basically just install Docker Compose. And to get the command for installation, I'm just gonna do Docker Compose. It will give me the install command. I'm gonna execute, and there you go. Very easy. Docker Compose should now be available. There you go. Another thing is that we are executing the Docker Compose command on the dev server, passing the docker compose.yaml file. If I do ls now, you see we don't have any Docker Compose YAML file here, right? Because that file is only in the repository. So the whole code is available for GitLab runner, but it's not available for dev server. So what we want to do is that we want to copy the Docker Compose file from the GitLab runner to the dev server, right? Before we execute Docker Compose command. So either in the before script or inside the script, doesn't matter, we are gonna execute secure copy command. We're gonna use this option to disable strict host key checking. We're gonna use the private key. And we're going to provide the source of the file and the destination. The source is current directory, docker compose.yaml, and the destination is the dev server and home directory of Ubuntu user. So that's the default location basically where the SSH command will be executed on in the Ubuntu user's home directory. So we want to copy that Docker Compose file right here. And that's it. So this will take care of copying the Docker Compose file to this location. And this will take care of then executing Docker Compose command using that Docker Compose.yaml file. So now we have those two changes. One is a new Docker Compose.yaml file and one is changes in our deploy script. And let's actually commit those changes and run our pipeline. And if I do commit, you see that we have an option to create a new branch and then start a new merge request, or we can commit directly to main branch. Now, usually In a typical developer workflow, you will be working with merge requests. So even if you don't create feature branches, you would still create a merge request and not commit it directly to main branch. In our case, we're just going to commit it directly to the main branch, which will then trigger a pipeline. And you see that pipeline was created, and you again have this different view of the pipeline. You have multiple ways of viewing your pipeline and links to it. In a web IDE, that's the view of the pipeline. So the run unit tests job is running in the test phase. And let's actually wait for the whole thing to execute. So our jobs ran. Again, we have an error in the deploy job, which is because we didn't stop the running Docker container before. So before executing a pipeline. So Docker Compose will not be able to stop this container because it's not defined inside the Docker Compose file, right? So it cannot reference it using the container ID, for example, or the container name, because it was not created using Docker Compose. That's why we have to stop it manually. And now we can actually rerun our pipeline. Let's do that. So this time our deployment worked. And in the logs, we see the copying of Docker Compose. And we can also check that. So we have the Docker Compose.yaml file on dev server. And if we do Docker PS, our container is running using the service name app that we defined in that Docker Compose.yaml file. Plus, when Docker Compose starts containers, it actually adds the folder. So the current folder's name as a prefix to the container name. So we have Ubuntu app, which is the service name, and one as a container name. And again, our application is running and accessible. And in the environments tab, we should see the last deployment was 8 minutes ago when we updated the Docker Compose.yaml and GitLab CI.yaml files. And if we open, our application is running and accessible again. So now you could add any other containers here on this Docker Compose list, like a database service, messaging service, whatever service you want for your application, and you wouldn't have to change anything in your CI/CD pipeline code. So let's close this pipeline view and do a couple of optimizations to this part of the pipeline logic. First of all, if we check Docker Compose command and this F command option that specifies the Docker Compose YAML file, you see that we have a default, which is Docker Compose.yaml, right? With YML extension. So this means if we are using Docker Compose.yaml, that's the name of our Docker Compose file, then we can actually leave out this option and have a little bit less code. And I believe it actually works with YAML extension as well. And we can try that. So let's remove these two since they are already the defaults. So that's one optimization. Another optimization is that currently we have the image name and image tag hard-coded in our Docker Compose file. However, when we're building new images, obviously the version of the image will be updated, right? So we don't want that to be hard-coded in the Docker Compose file, so we have to manually adjust it all the time. Instead, we want that to be dynamically set with the pipeline logic. So what we're going to do is we're going to parameterize this, and we're going to reference these values using environment variables. So we're going to do image name. So that's going to be one environment variable, and image tag will be another one. And note that we have a syntax here with $ curly braces. So that's how we reference environment variables in Docker Compose. And this way we don't have to hard code those values. So now that we're referencing these variables, we have to also set them, right? So basically what we are looking for is before we run the Docker Compose up command on the dev server, we want to export those variables, right? We want image name equals whatever the value, and then image tag equals whatever the value. And we want our pipeline to export those environment variables. How we do that? Very simple. Right here, before we actually execute the Docker Compose down and up commands, we're gonna do those exports. So we have image name, and we have the image tag. And right here we can actually hard code the values, but we don't want to do that either. Instead, we're gonna reference those values right here, right? So now we have a lot of references. However, the good thing is that we have one place where we define the values for image name and image tag, which is in the variable section. And then wherever we need that, we just reference them through variables. So we just take the image name like this and image tag and set them as environment variables on the dev server. And we have to do end, the end of each command. And note that these two can be different, right? So this is an environment variable inside GitLab Runner, which we create right here using the variables. And these are the environment variables that we're setting on the dev server, which are referenced in the Docker Compose file. So this could actually be Docker Compose image name, Docker Compose image tag, and we're gonna set them like this, right? So these two do not have to be the same. So with these optimizations, we can run our pipeline again. So this time we're not gonna start the Docker containers or the Docker container. It is still running. We're gonna commit directly to main branch, and the pipeline will build and deploy a new image to the dev server. And since our pipeline has passed, let's just validate that everything was successful. Go to environments, last deployment, and the application is still running. So now we have a Docker Compose that doesn't have hard-coded image name and image tag inside, as well as we have a little bit less code by eliminating the default Docker Compose.yaml file as a parameter, because that's a default. With that, we now have a basic structure of a real-life pipeline for our application that runs unit tests, builds an image, pushes that image to a Docker registry, and then deploys it using Docker Compose on a development server. And we have everything parameterized. We're not repeating code or hard coding different values throughout our pipeline logic. At this point, our pipeline looks like this. We have 3 stages where we're running the tests and then building and pushing the image and deploying it to the dev server. So we have created a basic version of a deployment pipeline for our demo application. In this chapter, we will add to that pipeline, do some optimizations, and make it closer to a real-life pipeline by first adding logic to dynamically set an incremented version every time we build an image. So we have a new version tag for our image whenever we execute a pipeline. And we're gonna add 3 more steps or 3 more jobs to our pipeline. First, we're gonna add static security analysis tests for our application, what's called assessed. And then we're gonna add 2 more steps right here to promote the application changes from development to staging environment, and then from staging to production environment. And of course, along the way, with all these additional steps, we're gonna learn some more GitLab CI/CD concepts. So let's get started. Now, in our pipeline, we have a hard-coded image tag that we had to manually adjust in order to build an image with a different version or with an incremented version. Otherwise, if we do not increment this version and just leave it at this hard-coded value, we will be creating the same image text and we will be basically overriding the image in our container registry over and over again, right? So if we keep creating an image with a tag 1.0, we will be basically overriding this specific image with every pipeline run, which is not very realistic and it's not what we want. The idea is that every time a pipeline runs, a new image with a new image tag gets built and pushed to the repository. Because as we develop the application and as we make changes, of course, we want to keep track of those changes and version them. So we're going to have multiple versions of our Docker image. And for example, if the latest version didn't work, we can revert or roll back to the previous working version. However, we want to automate this process of setting the new incremented version for our image tag. We don't want to have to set this manually each time. So we're going to add the logic here that sets the new image version every time the pipeline runs. So first, let's see how versioning applications works in general. For versioning applications, we have multiple options. Different teams use different version schemas and approaches to that, but a standard, very common versioning schema is made up of 3 numbers, like this. So we have the first one, which is the major version for major application changes. This could be like a big code refactoring in our application, or changing or replacing a programming framework, for example. Then we have a second number in our version for minor changes. So that's the minor version. And this could be if we add a new feature or if we did a little bit bigger bug fix and so on. And the third one is what's called a patch version, which is meant for small fixes and changes like changing a button in the UI or making a smaller bug fix and so on. And this whole version is usually defined in the configuration file of the packaging tool we use for that application. For our application, we use npm, and the configuration file for that is package.json. So this is where the version of the application is usually defined. So we have a version attribute and a version schema here. And in our case, for our pipeline, we use this random image, which is hard-coded, but usually the image tag is based on the application version, which is defined in this configuration file. So when we make application changes in the code, depending on whether these are major changes or minor changes or even smaller changes, we're going to increment the respective number of that version. So if we make a quick fix, for example, we're going to increment the patch version. If we make minor changes, we're going to increment this version and so on. So what we want to do now is in our pipeline, in the GitLab CI file, we want to read the application version, which is defined here. Let's make it bigger, programmatically. So in the job where we're building the image, instead of having this hard-coded image tag value, so let's get rid of it. Instead, we want to read that value in the build image job where we need the value. We want to grab that from the package.json file programmatically. How can we do that? It's pretty easy. We're going to cat the contents of the package.json file. So inside the app folder, we have package.json. And then there is a tool called JQ, which is a JSON query language that lets you parse JSON, a JSON object, and get an attribute of that JSON object, like version attribute, for example. So JQ minus R and the version tag. So this simple expression here will basically print out whatever the package JSON contents are, and then using this JQ or JSON query language, we're gonna grab the value of version attribute. And that's how we read the application version in our pipeline code. Now, in order to use this JQ tool, of course, we need to install it first. So on the runner that executes this build image job, which is in our case, this EC2 instance, EC2 runner with shell executor, this runner has to have JQ tool installed so that it can execute this command. So before we continue, let's go to our GitLab runner and install JQ, which is just one simple command. So going to my terminal, I'm going to connect to my GitLab runner with the GitLab runner key and using a simple apt-get install JQ, let's install that tool. Awesome. So to demonstrate how this works on a shell, let's grab our package.json just for a test. I'm going to create package.json file here, paste the contents. So now I have this package.json, and if I do cat package.json and pipe it to JQ tool that we just installed, this is going to give us JSON object. So that's how it's going to be without the JQ. So we have the highlighted syntax. And again, if we want to access a version attributes value, we're just going to do .version and we get the value. The same way we can access any other attribute value that we want. Pretty straightforward. So let's go back to our configuration. So this is gonna give us the application version, which we want to, or we need to save into a variable, right? So we're gonna actually save it into an environment variable, and we're gonna export that. Let's say app version equals whatever this expression returns as an output. So whatever this gives us will be saved into an environment variable called app version. And now we can use that environment variable in our script. And by the way, we can take this script and add it in a before script section like this. So this is kind of a preparation for whatever main script or main logic we want to execute right here. So now we can grab that environment variable and use it here like this. So this is a first step of reading the application version from the package.json instead of hard coding it in the pipeline. And this means the developers who are developing the code, the application, are the ones who are going to manage the application version in the package tool configuration and not in the pipeline. So pipeline shouldn't care what the version of the application is. However, now we have a problem that someone needs to manually adjust this version here, right? So on every commit, on every pipeline execution, basically, this version should be updated manually or we're going to be building the same image tag again. So we're going to be overriding the image and have the same problem of not having versioned images for our application changes. So that's the second part that we're going to implement now. So we want to generate a unique tag for our image on every build. And how can we do that? Well, as part of our application version, we can use values of one of the GitLab's predefined environment variables. So if we go to the predefined variables list and search for something like pipeline ID, this, for example, will give us a unique ID of the pipeline, either on a project level. So for my Node app CI/CD project, each pipeline execution will have its own ID, or we can also grab a unique ID of a pipeline across multiple projects that I have in the same GitLab instance. In our case, let's go for a unique pipeline ID for the project because we're building the Docker images for our project. So it has to be unique for that specific project. So I'm going to grab this variable and we're going to use that as part of our application image. So it's very common when building images in a CI/CD pipeline, generally on any CI/CD platform like Jenkins or GitLab, doesn't matter. It's very common to append the build number or build ID value to the application version. So either append it right here as some unique build ID, or even use it as a replacement or substitute to the patch version. So this will basically represent some build ID or build sequence, or in our case, a pipeline sequence. And this number will be unique for every pipeline execution. And this will give us a unique image tag with every build. So let's try to combine this and build our images with a dynamically set unique version. In our case, let's actually go with the pipeline ID as a substitute to the patch version, which means as a version, we're going to set major minor version, and we're going to append this third version in our pipeline. So for that, we are first reading whatever that version is from the package.json and saving it into a variable. And let's actually call this package.json version. And then on the next line, we're exporting the final version, and we're using package.json version. So whatever is defined here, 1.0 in our case, and we're appending the CI pipeline's ID for the project at the end. So this will give us the 3 numbered version schema, where the third or patch version will always be unique. And then when we build the image, we're going to use this final version instead, like this. Now, using this approach, whenever developers make application changes and they commit them, a pipeline will get executed and the patch version will be incremented. Now, if they make any minor or major changes, they can go to package.json, adjust the version here as part of the application code changes, and this way they can increment major or minor versions. So this will still be done manually. However, the patch version on every commit will be automatically incremented in the pipeline. Now, of course, you can extend the logic to automate updating or incrementing these 2 versions as well, but at this point, automating the patch version update should be enough. Okay, so now we're building the image with a new unique version on every pipeline execution, but we also need to push that built image, which means we need that version that we just calculated and put together in this build image job. We need that version also in the push image job. But here's the problem. Since we're setting this as an environment variable for build image job execution, the value of the version environment variable is only accessible for this job. For any following jobs, this will not be accessible because, as we've learned, every single job gets executed on its own new environment. All the previous configuration stuff for the previous jobs gets discarded. So any environment changes or configurations set here will not be available for the following jobs. So how do we access this value inside the push image or then deploy to dev jobs? Now, we could also calculate and put the version together in those jobs, but we don't want to repeat the code and have such a redundancy. So how do we share any values that we produce in one job with the following jobs? Well, that's where the concept of artifacts comes in again. We already learned about the artifacts in the video about running tests where we exported test reports. So artifacts is generally used to generate any files or artifacts as a result of a job execution, and we can then download these artifacts in the GitLab UI. But we can also use artifacts to pass these generated files to the following jobs. So artifacts is used in GitLab CI/CD to pass any intermediate build results between the jobs. So in case of the test reports, we generated reports to download them and maybe view them in a respective software. In this case, we can use the artifact to generate a file that contains the version that other jobs can access. So let's see how to do it. It's actually pretty simple. In the build image job, we create a simple text file that contains the value of the version's environment variable. So after we generate this version, we save its value to the text file. So we're going to do echo version, and whatever that echoes, we're going to pipe it or direct it into a file, and let's call it versionfile.txt. So it's a simple text file. So this creates a file in this job. However, we have to persist this file so it's going to be available for the next jobs. And in order to persist a file, we're using the artifacts attribute. Using the path attribute, we're saying, please persist this version file.txt as an artifact so that we can, one, download it and browse it in the UI, but also can be available for the following jobs. And that's it. So this will make sure that the file is available for the rest of the pipeline. Now, when the build image job is done, the version file.txt artifact will be uploaded to the GitLab server, and it will be then downloaded in the execution environment of any following jobs. Okay, so we're saving the version file in the build image job. Now let's see how to use it in the push image job. Or how do we reference an artifact saved by a previous job? Now, to access the contents of this file, we will simply print out its contents, just like we did here with the package.json. So we're just going to say, give me whatever is inside that text, and the same way we can assign it to a variable. So let's call this variable version. And whatever the results of this command execution will be saved into an environment variable called version. So now we have this version value also available in the push image job. Now the question is, how does the version file.txt artifact become available for other jobs in the pipeline? Do we just have access to it by default in this job, or do we need to do any extra configuration to actually get that file? Because in this logic, we're just assuming that file is there for the push image job without any extra configuration. Well, by default in GitLab, all the artifacts of the previous jobs will be automatically downloaded and made available for jobs in the next stages. This means if jobs in test stage and build stage produce artifacts, all of these artifacts will be automatically downloaded and made available for all the jobs in the next stages. In our case, the next stage is deploy stage. So deploy to dev job will have these artifacts automatically. We won't need to do anything there. We can just simply read from it, assuming it is available. However, the push image job is in the same stage as the build job. They're both in the build stage. So this rule that artifacts are automatically downloaded and made available does not apply here because it's in the same stage. So what do we do in this case? Whenever we want to use an artifact from the job in the same stage, we need to use an attribute called dependencies on the job to tell GitLab, please download artifact that this other job created and make it available for this job as well. Not just the following stages, but for the job in the same stage as well. So the dependencies attribute basically is a list of any jobs from which you need to grab the artifacts from. In this case, it is the build image. So with this configuration, even though push image is in the same stage as the build image that is creating this artifact, we will still get that version file artifact and be able to use it in the push image job. So with all this configuration, now we're specifying that in the build image, we want to save this file as an artifact, as a job artifact, which means once build image job completes, the artifact will be uploaded to GitLab server and basically persisted and saved there to then be downloaded in other jobs. Then GitLab will execute the next job in the same stage, which is push image, it will see there's this dependencies attribute that references the build image. So GitLab will download all the artifacts that this job generated. So this could be a list of files and directories, whatever artifacts we wanted to save here. So it will download all those artifacts in the job execution environment of this job and make them available for use. So that's how it's going to work. So we're going to read the version, and we will need to replace the image tag with this version environment variable. Now you probably already noticed that we're using both dependencies and needs attributes together. And these two actually seem to have similar meanings, right? We're saying the push job needs build image job, and it depends on the build image job, right? So it kind of sounds like they're doing similar things. So here's how it works. Needs and dependencies attributes have different purposes, but they do overlap in their functionality. So the needs attribute specifically says that push image job needs build image job to complete, so to be done and complete before push image job can start. And it actually needs the build image job to complete successfully before it starts. So if the build image job fails, then this should not be executed, which is logical because we can't push an image that we haven't built. Great. Now dependencies, as we said, is the main purpose of dependencies attribute is to tell GitLab that this job needs an artifact from the build image job. And again, this is only needed if they are in the same stage. However, there are actually overlaps on needs and dependencies attributes, and when they are used in combination, they actually affect each other. One of the overlaps is that when we use both attributes on a job, GitLab can only download artifacts of the jobs that are listed under needs. So for example, if we had some other job here like this and not build image, then this will not work. We would actually also have to include build image in order to be able to download the artifact or use this dependencies attribute. So in this specific case, needs will actually affect the functionality of dependencies. And another interesting overlap is that when we use needs, it actually already implies the dependency, which means in this case, GitLab will wait for the build image job to complete before starting push image, but it will also download any artifacts from that build image job. And as a result, we actually do not need to use dependencies when we have needs attribute already, because this will be implicit dependency as well. So again, important to differentiate that needs and dependencies have different purposes, but when used in combination, they actually affect each other. Now let's say in the next stages, we have several jobs that don't need that versions file at all. Let's say after deploy to dev, we have another job here that tests the deployment on dev. So test dev, and we have a script here that basically does some testing, but it doesn't care about the version because we don't need that in the logic for testing. In this case, we can actually tell GitLab not to download the artifact files from jobs of previous stages, because as I said, by default, that version file artifact will automatically get downloaded for this job if it's in the next stage. And we can actually prevent that from happening by setting the dependencies to an empty array. So this will tell GitLab, do not download any artifacts of any jobs of the previous stages. We don't need them here. And this can be helpful if you're producing a lot of artifacts in your pipelines and you don't want to waste your bandwidth and time for fetching all of them from internet for jobs that don't actually need those artifacts. Or it could be that your job only needs artifacts of one of the previous jobs, so you can specify only that one on the dependencies list. So let's say here we need an artifact that the test job produces. So This will make sure that only the artifacts of run unit tests build will be downloaded and made available for this job, and not the others. So basically with dependencies attribute, you can control which artifacts from previous jobs get downloaded and which don't. So let's clean this up, and we're gonna now use the version or read the version in deploy job. So right here in the before script of deploy job, I'm gonna add exporting version environment variable, reading from that file. And again, we don't need to specify dependencies here. It will be automatically available. And I'm gonna copy the version and replace the image tag with it. Now we can search if we have any image tag left in the pipeline. That's it. So instead of hard coding the version, now we are incrementing the version on every pipeline run, and we are using that incremented version to build the new image, to push that image to the repository, and then to deploy that new image to a deployment to a development environment. And everything looks good. So now let's commit our changes and see the output of the pipeline execution. Edit dynamic version increment for patch version. And I actually need to do that in the root directory. So let's check again. Git commit amend. So we're adding this in the same commit, and let's push our changes, and this should actually trigger the pipeline already. So let's go back, and our pipeline is running. So let's wait for the output. Then we're gonna see the image tag that we built. So first of all, our pipeline has passed through all the stages, which means we should have a new Docker image in our container registry. So let's go inside in our root image, and right here you see the base version, which is the major minor version in the package.json. And then we have the unique ID of the pipeline build, which is 121, which actually corresponds to the number of times we have run the pipeline. So in my case, I have 97 here, but I have deleted some of the pipelines. So in total, that will actually be the number of times the pipeline has run. And that means if we change something in our code, and let's actually change something that we're gonna see in the deployment. And let's say right here, let's do software engineer instead, commit. And once the pipeline has passed, let's again go to our registry and check the image tag. And as you see, we have a new image tag with a patch version, which has incremented from 121 to 122. So that's the number of pipeline execution in our project. So if you don't have any pipelines deleted in your project, you should see the number here as well. With this, we have optimized our pipeline, and instead of manually changing the version, we are incrementing the version automatically with every pipeline execution, which is exactly how the real world pipelines for applications should work. And this way we're building a history of Docker images for each application change. So if we want to go back to a specific Docker version, then we can use that image tag to deploy that specific image. And we can also check the deployment. If I refresh, right here we have software engineer instead of software developer, which is the change that we made. Now, there is one more thing I want to teach you about regarding the sharing of artifacts between the jobs. What we learned in our demo is a generic way of producing any file with any value and making it available for the next jobs. But in our case, we are saving and passing an environment variable, which we read out from the file again and export it as an environment variable. And for that specific case, GitLab actually has a dedicated feature to pass environment variables between the jobs. So let's see how that works. It actually needs a little bit of adjustment. First of all, instead of saving the environment variable file into a .txt file, we need to save it into a file with .env extension. So let's say this is build.env or env file. So that's where we're saving it. So that's the first adjustment. And we need to actually save the environment variable key value pairs, not just the value, not just one thing, but it has to have a specific format. So basically, we're gonna save version equals whatever the value. So this could also be image tag, it doesn't matter. We're gonna call it version for consistency. So we need to save environment variable equals whatever the value into build.env file. And you can save multiple such variables, environment variables, into the build.env file, say my env and some value. But in this case, of course, we would need to append each key value inside the file, right? So instead of overriding the contents inside, we would basically do this, right? Which is a syntax. It's a simple shell, Linux shell syntax for appending a value inside the file contents instead of overriding everything. So that's basically going to be the way we save that environment variable into build.env. And here in the artifact, instead of this generic path, we're going to say reports, and then inside that .env attribute, that references which environment file we are saving. So this is specific for environment variables. And now in the jobs where we actually need that value, this environment variable that we are saving here will be automatically available as an environment variable. So GitLab will actually do this, exactly this part. So export version equals whatever is inside for you, which means you don't even have to read it out from the file and then set it and export it. This will be basically done for you, which is super convenient because you don't have to worry about reading the values out of the file. It will automatically get exported and made available for you. Same goes here. You don't need to read it out of the file. Now in this case, same rules apply when it comes to using these dependencies and needs. So the dependencies attribute that we talked about and how these environment variables are made available for the jobs applies exactly the same way as for the generic artifacts, which means for the jobs in the next stages, it will automatically be set. For the jobs in the same stage, you need to either have needs or dependencies attribute. And again, the same way you can decide not to inherit those environment variables. Let's say if you have jobs where you have your own environment variables with your own version, value, whatever, you can actually set it to an empty dependencies array, which tells GitLab do not inherit or set any artifacts from the previous jobs here. We don't need that. And we can also run this and test that it works with this configuration. Set .env artifact. And as you see, the push image job was successful. We have a pass state. This time, there was no need to download any artifacts because it's an environment variable that gets set in that jobs execution environment. So we don't see logs about artifacts being downloaded. And right here, the docker push image name version command has succeeded because the version environment variable was automatically exported for the job. So as you see, when you want to pass environment variables, this is actually a little bit more optimized way of doing it. In our case, it doesn't really matter because we have just one environment variable value. But if we had 5 different environment variables that we wanted to pass to multiple other jobs, then this will actually be the correct and much better option to use, because it would be hard to read 5 different environment variable values from a .text file, because how do you parse them, right? But with .env feature, you don't have to read those environment variables. GitLab sets them automatically by default for your jobs. In our case, we can actually stick to the generic option of passing values between the jobs, just to learn the concept of how to do it for any file and any value, not just environment variables, and we can continue our demo with this option. Now, there is one more thing we should optimize in our pipeline to make the jobs faster and more efficient. And it's something you would always need in your CI/CD configuration. And that is caching. So let's see what it's about. Now, as we have learned, each job runs in its own isolated environment independently from other jobs. So everything we configure for one job, like setting environment variables, creating any files, etc., will not be available for the following jobs. They will start from a fresh environment, and that's great because it means the jobs don't affect each other and you have no unexpected side effects because of that. However, there are some cases where you need to share some files between the jobs. And we have seen some examples like this. Early in the course, we learned about the concept of artifacts, which we used for 2 things. One, to save files generated by a job to make it available after the pipeline has completed. So you can download them from the GitLab UI, like test reports. This could also be security scan reports, code analysis reports, etc. So every such job can basically generate its own reports, and you can then download all of them right here. In addition to having those artifacts available for the download like this, we can also use them to save files that other jobs will need. So artifact is generated during the pipeline in one job and made available to the following jobs. So its usage is to share files within the pipeline. But let's consider the following use case. In our pipeline, we have a job that runs unit tests. But before we run the tests, we need to install dependencies first using npm install or npm CI command. And npm install will fetch from the internet all the dependencies defined in the package.json file and save it into node modules folder. So if I go back to the project, the npm install will basically install any dependencies that we have in the package.json, in our case these 3, and these dependencies will then be saved locally in the node modules folder. Now let's say we had another job after run unit test job, like run code analysis, for example, that also needed to install the dependencies, right? So in this case, npm test uses those 2 dependencies because that's the tool in which the tests are written. And let's say for code analysis, we had some other tools that we defined in the package.json. So in order to run that code analysis, we would need to first install those dependencies. So we would have to do npm install again for that job. But since the job will run in its own new environment, it will have to fetch its own dependencies in the node modules folder itself. It cannot reuse the node modules or the dependencies installed by this job. And we could have another job that maybe compiles and packages the front-end code that will also need to install dependencies separately. So they're all installing the same exact dependencies because they can't reuse the dependencies from the previous job. And if your application is complex and you have a lot of dependencies in your package.json, and this could be a list of 100 third-party modules, then you can imagine that it will take a lot of time and bandwidth to fetch them in every job that needs those dependencies. And this will make our pipeline slow because installing dependencies, fetching them from internet does take a lot of time. And every CI/CD job requires some kind of a job or multiple jobs that installs dependencies. So when one job installs the dependencies and creates the node modules folder, we need a way to share this folder with others so they don't have to go through the same process. And at first, this may sound like a use case for artifacts, sharing files or folders between the jobs. However, what we also need is that the next time the pipeline runs, we want to reuse the node modules from the previous pipeline run. Plus, with artifacts, we know that the files that the job generates will get uploaded to GitLab server, which is another machine, and then it will get downloaded again on the GitLab runner for the next job. And it is obviously fine for 1 or 2 files, but in node modules, we have a bunch of files and folders for those dependencies. So uploading them to GitLab server and downloading them each time will not be a big optimization. So you will still need a lot of time and bandwidth to fetch them. And also consider that once you have the first ready version of your application, you're not going to change the dependencies very often. So this list, as well as the node modules folder, will actually stay pretty much the same for long periods of time. So now if your team pushes changes every couple of seconds, these are a lot of pipeline executions during the day, which would do unnecessary fetching of dependencies for every job. And if we could reuse the dependencies, that will speed up your pipeline executions a lot and save you a lot of bandwidth. And that's exactly what the GitLab CI feature of caching allows us to do. So what's the difference between how artifacts and cache works? As I mentioned, artifacts get uploaded and saved in the GitLab server and made available for following jobs. And it's used to pass artifacts to the following jobs. Cache, on the other side, is used to store runtime dependencies that the project needs and is passed between jobs in any direction. And cache, unlike artifacts, is not stored on the GitLab server, but rather is stored on the GitLab runner. So on the server where the GitLab runner is installed. And this means when your jobs run on the same runner, they can reuse the cache directly, locally from that runner's host machine. So they don't need to fetch anything from the internet. And when you have 1 or 2 runners for your project's pipelines, this makes total sense because the jobs will always get executed on these 2 runners, which already have the cache. However, if you have 100 runners and jobs get randomly assigned to them, then caching may not be as efficient because you would need to create cache on each runner's server. So when one job runs and creates this cache for node modules on one GitLab runner server, the next job may get executed on another machine which doesn't have the cache yet. So it will have to generate the cache again. So it kind of defeats the purpose of storing the cache on the runner's server. So for that use case, you can also configure what's called a distributed cache storage, like an S3 bucket, for example, from where they will fetch the cache. So you can have a central cache storage for all your jobs, no matter on which runner they get executed. A downside of that is, of course, that you would need again to download that from this remote storage. So fetch that from internet. But it's still more efficient and faster to download a zip file of node modules and unzip it than install dependencies from scratch. Okay, so now that we know what cache is and how it's different from the artifacts and that it's used to store runtime dependencies, let's see how we can configure a cache. And it's pretty simple actually. We create and configure cache in the GitLab CI.yaml file using a cache attribute. And just like artifacts, you can define cache configuration for each job. So right here in run unit tests job, we can add a cache which will basically generate the cache for node modules folder. So while it generates the artifacts for the test reports, it will also generate the cache for node modules that the following jobs can reuse. And there are 2 things that we need to configure a cache. First is the name of the cache or the cache key. And this is a string and we can name it whatever we want, like my cache. And the cache key is actually very useful because it will ensure that you are fetching the right file for the job. or the right cache for the job, because you can have multiple caches, and of course you need to make sure you're using the right one for the other jobs. A common use case for naming the keys of the cache is when you have multiple branches and you're running pipelines for all those branches, you can use the branch name as the cache key. So this way, whenever the pipeline gets executed for a main branch, then all the jobs that run for that specific branch will use the same cache and not a cache from another branch. And again, we want to dynamically set the name of the branch and not hard-code it. And for that, we also have a predefined environment variable. So if we check the list of predefined variables, we have a variable called commit ref or CI commit reference name, which represents the branch or a tag name for which the project is built, or basically which triggered the pipeline. So we can take this environment variable as the value of the cache key and use it here. So that's the first attribute. The second one is the location of the cache. So where are we saving the cache and where are we accessing the cache? And this is represented using a path attribute. And under that, you have the location of the cache. And since our node modules folder is inside the app directory, we're gonna specify that path. So app/node modules will be the directory where this job will expect to have the cache, because that's where we need the node modules to be available when we do npm install. And there is one interesting thing to mention here, is that in this job, cache will have two different purposes. One is to generate the cache so that any other jobs who also need this node modules cache available, they can use it. And the second one is to also download the cache. So the very first time we run the pipeline with this cache configuration, the run unit test job will generate the cache. And the second time the pipeline runs, the same run unit test job can actually reuse its own cache that it generated in the previous pipeline run. So the second usage of this cache in the job will be to download that cache and use it for itself. So generate and download. And that is what's called a pull push policy. And that's an additional attribute in the cache called policy. And in this case, the value of policy would be pull push. And as I said, it will mean that the unit test job will download the cache at the beginning of the execution, and at the end, when the job is complete, it will upload any changes to the cache. Yeah, however, this value is default, so we don't have to specify it. So we can just skip it and leave it like this. Now, just for the demonstration, let's actually add another job right here that will run on the same runner. Let's say this is going to be a linting job that also needs to install the node modules. And if you don't know, linting is basically an automated way of going through your source code and checking it for any programmatic or stylistic errors. So let's create this job, or let's simulate this job, and let's call it run lint checks. And let's say this is gonna run on the same runner with Docker executor. And this is also gonna be in the test stage, like this. So in the before script, we also need to do npm install, because let's say we are using some lint tool in our project that is a third-party module, and we have that lint tool dependency basically specified right here. So before we execute the lint job, we need to first download those dependencies. So just like in the unit test job, we're gonna cd into the app folder and then do npm install or npm CI command here. And then in the script, let's just simulate using an echo that says running lint checks. There you go. And note that because they are in the same stage, which is a test stage, these two jobs will run in parallel. So we don't know which one will complete first. They will be running in parallel. And since we are also installing the dependencies, we can use the same cache configuration here and copy that cache configuration and paste it in here, doesn't matter where. So we're referencing the same cache as here, and the location is the same because we need the node modules in the same directory here as well. And for this job as well, if we don't specify the policy of the cache, by default it is gonna download the cache when it starts executing the job, and when it finishes it will upload the cache. The problem is though, when we have two jobs or multiple jobs running in parallel that are using the same cache and then uploading or updating the same cache, we may actually get problems because this is a storage with some data, and then two different processes updating the data at the same time may lead to some problems. So what we can do is we can make one of them, so one of these cache configurations, read-only. So basically we can set a policy here that says you're allowed to only pull the cache. So do not update or upload anything to the cache when the job is done, only download it and use it if it's available. So that's where actually the pull policy comes in handy if we want to avoid any issues when updating the cache. And in many projects, people actually have a dedicated job for just creating the cache or generating the cache, and this would be called something like setup or build cache job. And the only purpose of that job will be to basically build the cache, and its policy will then be push, because it's not gonna need to read the cache. It is only there to generate and then update it. So when you have that job, a dedicated one for building the cache, managing the cache, you can then set the cache policy to pull on every other job and you don't have the problem as well. In our case, let's keep it simple and let's leave it like this. And notice one thing, that even though we're using the cache, we always still need to do npm install command. So after the first pipeline run, we can expect the cache to be there, but we're still doing the npm install. And that is one of the best practices of using cache in general in GitLab CI/CD, is that your job should never depend on the cache being available. So even if the cache is empty or it just got invalidated or something happened to the cache and you don't have access to it, your job should still be able to run successfully without depending or needing the cache. So cache is kind of optional, nice to have to speed up the job and to optimize the pipeline, but it shouldn't be a reason that your job breaks if the cache is not there. So we have our configuration for cache ready. However, at this point we have one problem. And the problem is that our jobs that are using the cache are being executed on a GitLab runner with Docker executor, which means when the job starts, a Docker container gets created and the job gets executed inside the Docker container. And this actually means that the cache will be created inside the directory of the Docker container. Remember I said that the cache is stored locally on the execution environment of the job. In this case, this is going to be the file system of the container. And what happens is when the job gets completed, the GitLab runner will actually remove the Docker container. And while artifacts get actually uploaded to the GitLab server, so it's actually persisted on another machine, cache gets stored on a local file system. And since containers are ephemeral, meaning whatever you create inside the Docker containers file system, by default also gets deleted. So containers do not persist any files or any data when they get removed. So those files do not get stored on the host where the container is running. But in order to make that happen, we need to configure what's called volumes. So if you have gone through my Docker course as a prerequisite of this one, you know that if we want that to persist, then we have to explicitly configure the Docker volumes, which will basically mirror, or it will replicate the data in the container on the host. So our goal with the cache is that we want to persist, we want to actually save that cache data on the machine, on the server where the jobs are running. So we need to fix that issue and basically configure a volume for our GitLab runner that uses the Docker executor. And it's not actually difficult to do. If we go to the runner configuration, right here, we have a directory called etcd GitLab runner. And inside that, we have to access it using the sudo. And inside that, we have this config.toml file. And that's the file where we can set different configurations for our runners. Config.toml. And this actually gets automatically generated when we install the runner. And as you see, because we have created two runners, we have the runner 1 with the shell executor, and then we have a runner 2 with this name with a Docker executor. So this gets generated automatically whenever we register a runner, and each runner gets added in this shared configuration file. And the things that we configured, like URL of the GitLab instance that the runner connects to, the token, and so on, all get stored here. So we can actually overwrite this configuration in here. In the runner section right here, we need to add an attribute called cache_directory, cache dir, and we're gonna set it to /cache, and that's the same location that is persisted using this volumes reference. So we're actually saving a volume of /cache from the container, and we're using it as the cache directory. Awesome. So we have configured our Docker executor to persist the cache directory on the host. So on the next job execution, the cache generated by the previous container should be available again. So we can save that, and now we are actually ready to commit our changes and then execute the pipeline. So let's do that. And make sure we are in the root directory, not the app. And let's call this add cache configuration. We can pull any changes and let's push. This will trigger a pipeline, so let's wait and see the result of this configuration. So both of the jobs in the test stage ran through. So now let's go and check the logs of each one of them to see the cache configuration. So first of all, we have the unit test job that is supposed to generate the cache. So if we scroll all the way up at the beginning, we already see the cache configuration. And here you see the name of the cache. And since we took the branch name as the key of the cache, we have the main. I have actually cleared the cache of the job 3 times. So I have an index of 3 here. You should just see main on the very first execution. And we see that cache is being downloaded, but on the first run, the cache is empty, right? So we don't have anything inside. And when we execute npm install here, you see that the packages actually get downloaded. It says added 557 packages. So all these packages had to be downloaded because we don't have a cache yet. And then at the end, when the job is finished, it is actually creating or generating that cache with this cache name in this location. And then we have a created cache success message. Now, if we go to the lint checks job and check its logs, let's see what happened here. So first of all, at the beginning, we have the same thing where we see checking cache, and that's the same cache key that we had in the unit test job. So they're referencing the same cache, that's what we want, and successfully extracted cache. In this specific pipeline execution, it just accidentally happened like this, that unit test job ran first and it was completed first, and lint checks job ran after that. So unit test job already generated the cache when the lint checks job started, which means the cache was already available for it. Again, this was by accident. They may run in parallel and not in this order. However, because the cache was already available, you see in the npm install command, we're not downloading any packages anymore. It says up to date, which means the node modules is already there. No need to download anything. And that's exactly what we want. And at the end, because we have a pull policy set on this one, it says not uploading cache due to the policy. So this one is only reading the cache. It's not uploading any changes to it. Now, let's check one more thing in our job. In the unit test job, we see that duration of this job is 48 seconds. So that's how long it took to install all the dependencies, run the test, etc. On the second run of the pipeline, because we already have the cache, this duration should be less because we already have the cache. So let's test this by running the pipeline again. And we're just gonna manually trigger it using run pipeline. First of all, we see the duration has dropped. Now it needs 20 seconds less to complete the job. And if we scroll up to the npm install command, it's not downloading the packages anymore. It says up to date. So the cache that it created previously is now available for it to use. And the lint checks should be the same. We have up to date again. So this is how you can optimize your pipelines and the speed of your jobs by taking advantage of the cache feature. Now let's go back to our pipeline code and let's remove this lint checks job because this was just for demonstration. But we're gonna leave the cache configuration for our unit tests so that our pipeline is a little bit faster. And finally, the last thing I want to show you is that whenever you want to get rid of the cache, there's a button here that says clear runner caches. So this will actually clear the cache on your GitLab runners. So when we run the pipeline again, new cache will be generated. But note that the old cache will not be deleted when we click on clear runner caches button. It will simply not be used anymore in the pipeline, but they still remain physically located on the GitLab runner. So if you actually want to delete that cache and maybe free up some space on your GitLab runners, you would have to SSH into the runner, locate the cache, and actually manually remove it from there. So this button is simply to tell GitLab not to use the old cache or old caches that we've generated with this pipeline and basically generate new ones. So let's actually clear our cache. Project cache successfully reset. And let's commit that change that we made, removing the lint checks job. And let's push that. This will again trigger a pipeline. And now if we check the unit test job logs, first of all, we see the duration increased again because we are installing all the packages now. And you also see the cache name changed from main3 to main4. So what happens here is that whenever we clear the cache doesn't actually get deleted. It is the old cache gets temporarily saved and you get a new cache with an incremented index at the end. And now there is one final thing that I want to show you that you might be interested in, and that is where is the cache actually physically located? Because as we know, it is saved on the GitLab runner machine, and since we're using a Docker executor, we're actually persisting that using a Docker volume, which means the physical storage is actually managed by Docker. And if I do Docker volume ls here, we have these two volumes, and that is actually a reference to the physical location on this machine, on the EC2 instance, where the caches are stored. So this is just the name of the volume, but to find out which physical location this references, we can do docker volume inspect and the volume name, and it will give us the location which is basically /var lib docker volumes directory with the volume name and underscore data. And let's check the contents of this directory. And first we have the folder with the name of my GitLab user. Let's go inside. Then we have the project name. And inside that we have two folders with the names of the cache, right? These are the keys of the cache. So even though we cleared the cache, it doesn't actually get deleted. It's just not used for the jobs anymore. So instead we have a new cache. And if we look inside one of them, let's say main4, there is our cache.zip file inside. So that's where physically the cache is stored when using the Docker executor. And we can also check the main3. That's the same cache.zip content here. If we're using a shell executor instead of Docker executor, then the location of the cache will be different. And GitLab actually has a documentation which describes generally caching and also the locations. I'm going to link this in the video description so you can check it out if you're interested. So right here we have the executor type and the default path of the cache. So for Docker, this is the var lib docker volumes with the volume ID, etc. What we just saw. And for a shell executor, it's going to be in the home GitLab runner /cache with the same folder structure. Awesome. So we've seen everything regarding the cache. We have optimized our pipeline. And now we're ready to move on to the next topic, which is GitLab job templates. Great, our pipeline is becoming more and more realistic and sophisticated, and we're learning different GitLab CI/CD concepts along the way. In this video, we're going to configure another step in our pipeline for testing the application code for security issues. It's called SAST, or Static Application Security Testing. And we will configure it while learning another concept in GitLab of what's called job templates, where in your pipeline you include jobs that GitLab already has available for you. And this is one of the important and powerful features of GitLab and its auto DevOps concept. So let's see what's that about and how to do it. Now in our pipeline, we're running unit tests, right? But when it comes to delivering and releasing application changes, of course, in real life scenarios, we want to do much more extensive testing because you don't want to release changes that will potentially break logic or performance of the application or introduce some security issues, right? So when you develop and add a new cool feature that you're eager to deliver to your end users, you have a trade-off of wanting to release it as fast as possible, but also taking time to test extensively so it doesn't break your entire application. And for that, we have many different types of testing. And this can be automated tests or manual tests as well. But ideally, we want to have enough automated tests that there is no need for manual testing anymore. So developers and test engineers will write a bunch of automated tests to test different aspects of the application. Unit tests are just one of them, and they're the simplest ones. Unit tests are used to simply check individual code pieces for correctness, like your functions are written correctly and they're giving the correct output, for example. You also have functional testing, which is used to validate all functionalities of your application. Then you have integration testing, which is used to validate the interaction between different parts of the application. So basically how it integrates with other services. And as I said, developers and test engineers usually create test scenarios and write tests for them. And when we release the application changes, all these tests can be run to test different aspects of the application. Now, the tests that I just mentioned are all application logic or functionality related tests. We also have tests, or we want to have tests that validate application security, like searching for any security issues or vulnerabilities, etc. One of such tests is what's called SAST, as I mentioned, which stands for Static Application Security Testing. And this is what we're gonna be adding to our pipeline in this video. Now what SAST does is basically review the application source code to identify any vulnerabilities that can make an application susceptible to an attack. And this could be any software flaws and weaknesses such as SQL injection, etc. You actually have a list of such vulnerabilities that you want to validate and check in your application code. And besides SAST, we also have what's called a DAST, which stands for Dynamic Application Security Testing, which is a testing method that examines an application's security dynamically as the application is running, in order to find vulnerabilities that an attacker could exploit. Now it's interesting to know when to run which types of tests in the pipeline. Integration tests, for example, require a deployed running application so that you can test it with other services that it integrates with, which means we can only run them once we have deployed the new application image to development or staging environment. On the other hand, we can run unit tests early in the pipeline every time we commit new changes. The same way, SAST tests should also be performed early and often against your application source code, while DAST should be performed on a running application in an environment which is very similar to production. So with this explanation, you should get a good understanding of the big picture of the CI/CD pipeline and different types of tests that you can run in that pipeline. But we're not going to go into details on how to write these tests or explain each type of test and when to run them, because it's not the scope of this course. Instead, we're going to focus on running SAST tests in our pipeline in order to showcase a functionality of GitLab that allows you to use existing GitLab jobs with everything already configured in it to include and run it in your own application pipeline. This means we don't even need to know how to write or execute SAST tests. We simply use the SAST job that GitLab makes available for its users. So how does that work? GitLab provides readily available templates for jobs for different programming languages and technologies. And one of these job templates is for running static application security tests. So in order to see how it works, we will use one of the templates and add a job in our pipeline that will run SAST on our Node.js application. So we are getting this functionality out of the box with very little configuration effort on our side. So first of all, what is a template in GitLab CI/CD? Templates are basically like already created GitLab jobs that GitLab makes available for its users to include them in their own pipelines. But template jobs compared to regular jobs are generic, so that they can be reused for multiple projects with any programming language or technology stack. And as the name suggests, you can pass parameters to the template jobs to customize its behavior to your own needs. So basically, GitLab engineers wrote a bunch of job templates for different languages and technologies, and you can reuse them without writing your own job configuration. And there is actually an official list or a repository with a list of those template jobs that you can browse and search and see what's available there. And you can find this list here. So that's the repository of GitLab, which contains a list of all these templates. So as you see, we have AWS, security, Terraform, a bunch of other templates for different tools and technologies right here. And one of the template groups or folders here is security, which contains templates for different security tests, like container scanning, image scanning. We have DAST jobs here, and we have this SAST job here. And we see here for this job template, they moved it to the jobs section. So going back to templates and jobs, that's where we have our SAST job template. So as you see, this is also a GitLab CI.yaml file. And if we look inside, it is written with the same syntax as we write our pipeline. We have the variables, we have the job names, and so on. So basically, by including this job or this YAML file in our GitLab CI.yaml file, we're merging these two and we're extending our pipeline with what GitLab provides us with. So basically, we take all these contents and make them available in our own pipeline code. Now, how do we do that? How do we reference this whole configuration or this whole code within our own pipeline code? It's super simple, actually. For adding or including any GitLab job templates in our own pipeline, we have a feature called include. And inside that, we can specify what do we want to include. And whenever we want to include a job template of GitLab itself, we specify a template and then the location of that file. So when we specify a template attribute here, GitLab knows that we want to include a job template from GitLab itself from this repository. And that's why we don't have to specify the whole address here. We only have to specify the path or location within this repository. So it's going to be jobs folder, and inside that, the sast.gitlabci.yaml file. So right here, we're going to do jobs and the name of the file, gitlab.ci.yaml. That's it. So this syntax will tell GitLab that we want to extend our own pipeline with some of the logic that GitLab provides us with in this specific file. So everything that is in here will become available in here when we run the pipeline. That's how simple that is. So it's like we're merging two pipeline codes in one. And we saw that there are regular jobs defined here for different technologies and programming languages. By the way, we have Android, iOS, and so on. And we have a job for Node.js. So when we include this in our pipeline, GitLab is actually smart enough to detect what language or what technology we're using. And it is gonna pick the right job from this entire list and only run that one, because obviously we don't need these other jobs for other languages and technologies, right? And in order to actually trigger the jobs that we're including here, we need to add the job definition in our pipeline. And let's find a right place for it. Let's say in the test stage, we want to run the SAST test as well. So unit tests and SAST tests will run in parallel. And to trigger that, the only thing we need to do is write SAST and add a stage, which is test in our case. So that's it. That's the whole configuration. This will actually trigger the SAST jobs that are made available in our pipeline using this reference. So let's actually commit those changes and see the result. And let's check our pipeline. And in the test stage, you see that in addition to our unit test job, we have 3 additional jobs that were added from this file. So we have ESLint SAST. So that's one of the jobs defined here. We have Node.js scan SAST. So we detected that we're using Node.js application, and the third job as well. We didn't have to specify any of these jobs. It was automatically included from the GitLab job template and executed in our pipeline. And we can check the logs of one of them to see exactly what is happening there. And you see that an analyzer process basically did code analysis. Let's check the other ones as well. And the Node.js scan SAST. There you go. And if we go back to the pipeline, we actually see that those SAST tests generated the reports for all 3 jobs. So if you have a software, an application that your team uses to visualize the SAST job reports, you can download these files, import those test reports into the software and basically have a visualization of your code analysis. Now note that besides the job templates that GitLab makes available for us, we have a second type of templates which are called pipeline templates. And these are basically configurations of the whole pipeline that you can simply take and use directly from GitLab. So instead of writing the GitLab CI.yaml file from scratch like we did, you can take one of the GitLab's pipeline templates for your specific technology stack and use that immediately with no effort or maybe a little bit of modification to basically create a pipeline for your application super fast. The way to do that is actually, if you have a project that doesn't have a pipeline yet, and you go to the CI/CD pipelines configuration, which is empty because we don't have a pipeline code here, and you scroll a little bit down, you see a list of pipeline templates that you can use in order to create a pipeline for your application. So depending on what tech stack you're developing with, for different languages, Python, PHP, Ruby, Node.js, etc., you can basically use that template. So when you click Use Template, this will actually give you a pipeline code which is directly available from GitLab with some boilerplate configuration for your application. So you don't have to write it from scratch, basically. That's the idea. Now our pipeline has an additional test step, which we were able to add out of the box with almost no configuration effort using GitLab's job template. Now to make our pipeline even more real life, we need to add one more thing, which is deploying to the production environment. Right now we're deploying to the development server, and that's the end of the pipeline. But in real life, you usually have 3 deployment environments. As I mentioned in the previous video, before you roll out a new feature to the end users or any application changes to the end users, you need to make sure those changes didn't break the existing logic or setup in the application or didn't introduce any security issues. So you release your application changes in stages. First stage is deploying to development environment, and on this stage you may run functional and integration tests to make sure the application still functions properly. And if those tests are successful, you move the changes, or also another term used for it, you promote the changes to the next stage, which is called either a staging environment or it could also be called a pre-production environment. And here you may want to run performance tests to make sure your application performs properly, like it didn't get slower because of the changes. And you may also run test tests to make sure your application isn't susceptible to attacks because of some security issues. And if those tests are successful and they successfully validate that the changes didn't slow down the application, there are no security issues, and so on, you can again move or promote those changes to the final stage, which is production. And this is the environment which end users have access to. That's your live end environment. And the concept of CI/CD means that the application changes will go through all these stages using the automated pipeline that orchestrates all these steps. So let's see how this kind of pipeline will look like by adding steps to deploy to staging and production environments. Well, first, just like we created a development server to deploy to it, we need staging and production servers or environments to deploy to. And we can create 2 additional EC2 instances for those, which would be how you would do it in real life. So you would create them exactly the same way as we created the dev server. No difference there. In our case, in order to save infrastructure costs and the effort of managing these 3 different machines, we're going to reuse the dev server for all 3 environments. And we're going to deploy the application on all 3 stages there, but on different ports. So the application will run in parallel on 3 different ports, and these ports will basically simulate a different environment. So development version will run on port 3000. When we promote it to staging, it will run on port 4000. And when we promote it to production, it will run on port 5000. Now you can choose any port you want. These are just randomly chosen ports. Doesn't matter. This way we can simulate these two additional environments on the same server. So let's get started. By going to our application configuration code. So the first change we're going to do is in the Docker Compose file. So in the deploy to dev, if you remember, we are copying the Docker Compose file and we are running the container using the Docker Compose file, right? We're executing Docker Compose up commit. So that's the blueprint of the deployment. So what we're going to change here is the port number. Right now it's using 3000 on the host. So the container itself, or the application inside the container, will start on 3000. So that's going to stay for all the applications. But when we run the containers, we are binding that containers port to the host port. And you know this if you've gone through the Docker prerequisite course. We are binding the container port on the host port. And this is going to be the port that we're going to make configurable. So for development, it's going to be 3000. For staging, it's going to be 4000. And for production, it's going to be 5000. Because you can't reuse the same port on the same machine, right? They have to be different. Well, this is going to stay the same. So let's parameterize this one and create a variable called application port, which we're going to configure or set in the pipeline. So this is going to stay the same. All the containers will start at port 3000, but on the host, they will be exposed on different ports. So that one is configured. Now let's go back to our pipeline definition and make changes here. First, let's set this environment variable that we just defined, which we called app port. And for consistency, let's actually call this DC or Docker Compose app port. Like this. And we're going to set it to 3000 for development, right? Like this. Now I'm going to copy this whole configuration that deploys to development server. And right here, we're going to create deploy to staging job that will basically do the same. It will take the private key of the deployment server. It will grab the version from the artifact from the build image job. It will connect to the server, copy the Docker Compose there, and it will start the service or start the container using the Docker Compose file, but this time on port 4000. Now the image name and the version will be the same because we are taking the same image and promoting it to the staging. However, we have some development server specific parameters here. So in a realistic scenario, we would have a separate dedicated server machine for the staging environment with its own private key, with its own host name, and with its own endpoint. So let's actually simulate this, even though in this case they're the same. Let's define them as in the real life example. So we're going to do staging server host and staging endpoint. And in our case, this is going to be the same. If we had a different server, that will have different values. But we still have separate environment variables for those. So I'm going to take this and use it in our deploy to staging job. So right here, staging server host. All these will stay the same because we have one Docker registry that all the environments can use. And here as well, we're going to have a staging endpoint. And we're going to rename this to staging. So remember, that's the GitLab environment feature that helps you visualize your different environments and the endpoints of the applications. Now the staging endpoint we said is available at port 4000 instead of 3000. So that's going to be a different value here. And with this, our staging deployment configuration is also ready. Now, one thing we're going to do is we're going to separate these two deployments into different stages. Because, of course, we first want to deploy to development server, then we're going to run some tests there. When these go through, then we will execute another stage for deploying to staging. So let's actually create those additional stages and call it deploy dev stage, deploy staging stage. And of course we have to create them here. And between those two stages, let's simulate a stage for running functional tests on a development environment. We can call it functional tests or test dev or whatever. So this stage will get executed after deploy dev is complete. Or we can also run it in the deploy dev stage and just make it wait for the deployment job to complete before it runs using the needs attribute. So you have different possibilities to do that. Let's go with the last option. So right here, I'm going to simulate run functional tests, and let's just create a simple script that echoes running functional tests. And this job will have a dependency on the deploy to dev job and will run in the same stage. So it's going to be part of the deployment stage where we basically run the tests to validate the deployment. And we can execute it on our own runner or on the GitLab shared runner, it doesn't matter, we're just simulating it, so we're just going to leave it like this. So with this configuration, we are first deploying to development, setting the port 3000 for the application, then we're running functional tests after the deploy to dev completed, and if that's successful, then deploy to staging job gets triggered and executed that deploys to a staging environment on port 4000. There is one more thing we need to adjust our configuration so that we can reuse the same Docker Compose file on the same server to start multiple containers. Right now, when this job deploys the container using Docker Compose file, it will create the service called app with those parameters, and it will start the container. Now this job will start, and before we start the containers, we actually have Docker Compose down in order to stop all the previous containers. And this will actually go through the same Docker Compose file, and we will see, okay, I have a service called app, and I'm gonna stop that. So it's actually gonna stop the container that this job started. And we're gonna fix that. So first of all, it's important to understand, again, you probably learned this in the Docker prerequisite course, but whenever we start a container using Docker Compose file, the name of the container gets composed with 3 different parts. So this is the dev server right now where the Docker container with the development version is running. And at the end, and the last attribute, so this one right here, is the name of the container. So this container started from the Docker Compose file that we have. So the name of the container is Ubuntu. I'm going to write this down here. Ubuntu _app1. So how does it work? The name of the service that we defined in the Docker Compose file is app. So that's the service name. And then we have the suffix that Docker Compose appends at the end. And then we have this Ubuntu before. So what is that about? Well, Docker Compose takes the name of the folder, the current folder that we're in, which is Ubuntu, and it prepends that name to the service name. So that's the default behavior of Docker Compose. So the service name or the container name will end up being whatever the current directory is, service name underscore the index, right? So what we're going to do is we're going to change the name of the container by overriding this value here and making it either dev, staging, or prod, so that the container created with the same Docker Compose file will have a different name depending on which job deployed it. And it's actually pretty easy to do. We have an environment variable from Docker Compose We can see that in the official documentation, which is called compose project name. So this will overwrite the prefix of the container name. And that's what we want to do. So we're going to set this environment variable value in each our deployment jobs. So right here, we're going to say export compose project name. And it has to be called this because it's an environment variable by Docker Compose itself. And here we're going to set it to dev. And let's copy that, set it here, and the value will be staging. So now using the same Docker Compose file, we can create containers with different names. So this means that Docker Compose down command in the staging job will actually look for a container called staging_app_1 and stop only those containers, and it will not mess with containers started from this job. So we have a separation. So let's actually make a small change in our application to see that change deployed on both stages. So let's change it back to developer, and we're gonna commit all those changes at once to our application. So make sure we are in the root, add all the changes, commit, let's just call it add deploying to staging, and push the changes. And see what happens. And our pipeline ran, but we have a failed deployment because I didn't stop the currently running container. So what happened is my current container is called Ubuntu_app_1. And since we have changed the name, it tried to create a new container with a new name on the same port, and it failed. So we need to actually stop the currently running container and reset the state so that our pipeline can go through. So no Docker containers running. Let's actually go back and execute the whole pipeline again. So deploy to dev is being executed, and the run functional tests is waiting for it to complete before it can start. So let's wait for that to complete. And our deploy to dev job just went through. Now functional tests will run. And in the meantime, let's actually check the logs. And it looks like it created the right container. And let's check that it's running. We have a dev app1 running on port 3000. Now let's wait for the deploy to staging to also complete. And deploy to staging was successful as well. So our pipeline is fully green. Let's also validate that the container is running. So we have staging app1, which runs on port 4000. And they're both bound to container port at 3000. Awesome. Now let's actually go to the browser and check both of those endpoints. First, we have the development endpoint. And by the way, we can rename this server to just deployment server or deployment environment instead of dev server. So let's call it deploy server because we're reusing it. And let's grab the public DNS port 3000, and this should give us the development version. And here we have developer, which is the change that we made. And second, we're going to check port 4000, but it's not going to be accessible yet because we need to open that port. So let's go to security, security group, edit inbound rules, where we have port 3000 open. So we're going to add port 4000 and port 5000 later for the production. Save the rule, refresh again, and there you go. So this is our development environment. This is our staging environment. Awesome. And let's do one more thing, which is simulating that the functional tests actually fail. So basically we deploy to development environment, then the functional tests run, but they fail, and this will abort the pipeline and prevent it from promoting the changes to the next stage, which is staging. So instead of echo, let's write some wrong command here. This should fail the job, and then staging should be skipped. So let's commit those changes. And let's see what happens. And as expected, the run functional test job has failed, and this prevented the deploy to staging job to be skipped. Great, so we have deploying to staging. Now we can add deploy to production. But before we add this step of deploying to production environment, let's do one optimization to our pipeline code. As you probably already noticed, these two jobs, deploy to dev and deploy to staging, have almost identical logic. So if we add the deploy to production job with the same logic, we will be repeating the code 3 times, which is not clean, and it makes the pipeline configuration hard to read and maintain. So let's follow the best practice of writing GitLab CI/CD pipeline configuration and clean up this code duplication. So the question is, how do we reuse the code inside GitLab CI/CD configuration? Well, for that we have another concept called extends, and it's pretty simple actually. So we take the code or configuration that repeats, in which case it is actually the whole thing, because we basically just took and copied the whole thing and just set some parameters. So we take this whole thing, and I'm gonna cut out that, and we create a generic base job from it. And let's call this job deploy. And this one will have the generic deploy logic. So now this is specific to development, obviously, because we have those values here. So we're gonna make this logic generic so it can be reused by different deploy jobs. First of all, let's remove the stage. So this can be defined by the specific deploy jobs. Since we're using the same GitLab runner, we can leave the tag, which all 3 will share. And there are 2 or 3 values that are actually different between the jobs that we use inside the script logic. So whenever we extend the generic job, we would need to pass those values for the specific deployment job. And we do that using environment variables. So SSH private key will be different for each deployment, especially if we are like in real life using different machines. The server host will be different, the application port will be different, and project name will be different. So these 4 values will be different for the specific jobs. So let's define them as variables right here. So SSH private key will be passed from the specific job. Then we have the server host, so we can make this generic and rename it to the server host like this. So this will be passed as a variable value. Then we have the compose project name, the value of which will be the environment. So let's call this environment or deploy environment. And this should be set from outside. By default, it's empty. The port, let's call it app port. And right here, we also have 2 additional values. Let's actually reuse that deploy env right here and call this endpoint, which should also be passed from outside. So we have 5 variables or 5 parameters in total that should be set to make this generic job into a specific deployment job. So right now, everything is parameterized. This is generic, customizable, nothing is hard-coded here. So we can reuse this base job and all this logic basically in the specific deploy jobs. So how do we do that? Super simple. We have a keyword called extends that specifies whatever job we want to extend. So it's like creating a hierarchy of the jobs. So we have a job, and everything defined here will be inherited by whichever job extends it, right? We also said that we're gonna specify a stage for each job, deploy dev. And of course, we have to pass the values for all those variables. So I'm going to copy them, and let's define variables list, and let's set those values one by one. First of all, we have the SSH private key that the base job deploy expects, and we have an environment variable which we created ourselves, so we can reference it here. Note that this environment variable can be named something different. It doesn't have to be the same. Then we have the server host, which is going to be the dev server host. Then we have deploy environment, which is development. App port is 3000, and endpoint is dev endpoint. That's it. So by extending the base deploy job, we're reusing everything that we have defined here in the deploy to dev job, and everything that is different or needs to be specific to the dev deployment, we are setting them using environment variables. And now let's do the same for the staging. I'm going to copy all of this. Let's remove the whole logic and extend the deploy job. Then we're deploying to staging. And let's set the variables. The SSH private key in this case is going to be the same. Then server host is going to be staging server host. The deploy environment will be staging, port will be 4000, and endpoint will be staging endpoint. I think that's what we called it. There you go. So now instead of having this whole code twice or 3 times, we have extracted it into a generic job, and we're just extending it or implementing it specifically by just setting a couple of variables, and that's it. Now, you're probably thinking, when we run this, we actually have an additional job, deploy. This is also going to get executed. So we have a deploy job that basically has no values for those parameters, so it's going to fail. So how does that work? So we need this job just as the base so that we can extend from it in deploy to dev, deploy to staging, and deploy to production. We don't want this job to get executed as a separate job, because again, we don't have any values here. This is just the base default thing. So how do we prevent this job from being executed? Well, we make it inactive. In GitLab CI/CD, you can make jobs inactive by making them what's called hidden jobs. And the syntax for that is simply dot before the job name. That's it. So when GitLab sees there's a job here that starts with dot in the name, it knows this is a job that is supposed to be extended. It's not supposed to be executed. And of course, in the extends value, we have to use that dot as well. And that's it. So this will prevent deploy to be executed as a separate job, and the problem will be solved. And now we can easily add a deploy to production job without repeating this whole code. Instead, just defining this couple of lines. So let's call these production, or deploy to prod for short. Deploy prod. So we're going to make a new stage for that. And the same way, let's actually simulate running performance tests after we deploy to the staging. So let's do run performance tests, and we have a script here that just echoes running performance tests. It will run in the deploy staging stage, and it will have a dependency on this job. So this job should run only after we have deployed staging, because theoretically these tests will run on the staging environment or against the application version on the staging environment. That's why it makes sense to wait for the deployment to staging before we execute the tests. If the performance tests are not successful, if they fail, we don't want to deploy to prod. If they are successful, we can deploy to prod. And let's set those values as well. The SSH private key will be the same. The staging will be the same. Let's create environment variables for the production. Let's call them prod, server host, prod endpoint. And again, in this case, we have the same machine, but in real life, this will be different. So we need a separate variable for that. And prod endpoint will have port 5000 at the end. And again, this whole URL will also be different in a real life use case. So we're not gonna extract it and reuse it. So we're gonna leave it like this. Let's copy that. Prod server host, let's call it production, port 5000, staging endpoint, so that we have prod endpoint. Awesome. So we have 3 deployment jobs that all extend from the base deploy so that we don't repeat the same code over and over again and make our pipeline configuration cleaner. Now there's one thing we want to add to production deployment that we don't have on the other 2 deployment jobs. Usually in real life projects, even after extensive testing, many teams do not feel comfortable deploying to the production automatically without any manual human review before the deployment. So usually the pipeline will go all the way to staging and run the tests, but it won't deploy to production automatically. Instead, it will wait for a human user input, like just clicking a button saying deploy, and we can configure that very simply in GitLab using an attribute called when and the value called manual. So this will tell GitLab, do not execute this job immediately, wait for a user input. So this job is supposed to be executed with a manual approval. We have one final issue with this configuration, and that is specific to a variable of file type. Remember that we created this SSH private key variable as a file type variable, right? And you also remember when we echoed the variable value, this actually gives us a path to a temporary file which has the contents of this SSH private key. So this gives us the location of the file on the GitLab runner server. And we're passing that value, whatever that variable value is, to another variable, which we also called SSH private key. This could be SSH key, it doesn't really matter. In this case, we just keep it the same. And this seems to be a bug in GitLab. Variable contains content of file instead of the file path. And this is an issue that a lot of people have, and maybe it gets fixed in the future, but it is a known bug. So what happens here is that whenever you pass a value of file type variable to another variable in your pipeline, instead of the path of the file, the content of the file gets assigned. So the value of this will not be the location of the file, which is what we need. Instead, it's going to be the whole content, this private key certificate content, and not the file path. And this will actually give us an error because in these commands, we need a file path. This is not going to accept the contents. It's just going to give you an error that says it's an invalid value or not recognizable or whatever. So we actually need the file path and not the contents. So we need to fix that or kind of work around this GitLab bug. So first of all, to avoid any confusion, let's rename this variable that our base deploy job accepts. So this one here to SSH key, right? So we're passing an SSH key variable in all the deploy jobs. And inside this deploy job, SSH key, as I mentioned, will reference the file contents. So what we're going to do is we're going to create a file here using those file contents. So we're going to echo those file contents and we're going to pipe it or save it into a file, and let's call it deploykey.pem. So that's the file extension we're using. And then we're going to use that file in all these different places where we need the file and not the contents. So that's going to be our workaround. So right here, we're going to do deploy key.pem, and the same in these two commands. So we're getting the file contents instead of the file path passed to our deploy job, and then we're converting those contents back into a file. So this will save the contents of the SSH key into the PEM file, this new file that we're creating, but we need to do a little bit of transformation of that contents in order to save it as a valid format of the PEM file. I promise the final issue that we're going to fix now is that the contents of this file variable will be provided as a one-line content, so to say, one-line value. So SSH private key is a multi-line file. We have the first line and we have these multiple 64-bit lines, and then we have this final line that says end RSA private key. So we need to transform the one-line value of this file back to multi-line. So we need to do this kind of transformation. And to give you an example of what the variable value will look like, so this is SSH private key, the variable name, that references the temporary file. And when we assign it to SSH key variable, then we get the contents, but as a one line. And you see here that instead of a new line, there is just space here. So instead of spaces, we want new lines. We can't do a simple replace space with new line here because we have spaces, unfortunately, here as well and at the end. So we need a little bit more advanced transformation. So let's go back to our code and see what that transformation code will look like. So right here, we're going to pipe this. So the one line value, we're going to use a Linux command called sed, which stands for stream editor. So we're editing that variable value, and we're going to do 3 different edits. So the first one will be to basically keep this begin RSA private key as one line and then do a line break afterwards. And that's going to look like this. So we're basically keeping this whole string, and then we're adding a new line after it instead of the space. So that's one thing. Then we have another transformation that is basically the same, but for the end of the line, which is end RSA private key. We're doing the same here. And then we have all the lines in between. So for those lines, we want to have them on separate lines, and instead of space character, we want new line characters at the end. And that transformation will look like this. So we have these 64 character strings basically. So each one of those lines has 64 characters, and at the end of them, we are adding this new line, right? /n is a character for new line. And you can check out the documentation of this sed command or stream editor command if you want to know exactly what these values mean. But in our case, this transformation should give us exactly what we want, which is from one line value of this variable, we're going to get this format that we see here, which is a valid private key format. So that's the last part of our configuration. And that was really the last issue that we had. And with this, we have completed our configuration. Let's not forget to fix this functional test job and set it back to echo, because we want to make sure the pipeline goes through. And now let's actually make a change in our application code to validate that the changes in the application gets deployed all the way to the production. And let's add here GitLab auto DevOps. And now let's go ahead and commit all those changes and see the result. So add deploy to production. Git push. So before the pipeline actually deploys to the development, we need to stop the container first because we changed the name of the container. So it will not be able to stop the currently running one. So the compose project name, deploy env, we changed it to development instead of dev. So we would need to fix that by removing the container first. So let's do docker stop the container ID. We can leave the staging because we didn't change that one. It's still called staging. So now our pipeline should actually go through. And if we check our pipeline execution, it looks like it went through without a problem. We have the deploy dev that passed and deploy staging that passed, and the deploy prod is basically waiting for a manual approval or manual execution. So let's first of all check the dev and staging deployments and make sure that our change was deployed. So if we refresh right there, we should see the change. Same on the staging. There you go. And right now, if we try to access the prod environment on port 5000, there is nothing deployed there yet. This is the first time deploying to the production environment, and we have to manually trigger it. So at this point, testers, project managers, whoever is responsible for the final decision to release to prod will basically check the application, will go through the test reports maybe and see that everything is fine. We'll see that performance tests have passed, and they may decide to deploy to the production. And when we have this manual step or manual approval attribute set on a job, you get this play button here or play icon that lets you manually trigger it. So this is equivalent to the general play button, which will let you trigger the whole pipeline again. And this is just for that specific job. So let's actually deploy. And you have the same thing on the list view right here, run manual or delayed jobs. And you can run this deploy prod like this. Let's go inside the pipeline and let's actually trigger this play button. And deploy prod was also successful. Now, if we refresh this, we should see the application deployed to production as well on port 5000. And now we have an optimized pipeline that is very close to the real life project pipelines with all the steps in between. So we have the test stage before we even build the application that basically checks and analyzes the code for security and functionality, the unit tests. Then we're building and pushing the image, deploying to dev, running tests on that, deploying to staging, running tests on that, and then manually deploying to the production. Of course, there are some additional steps to make it even more production ready and closer to the real life pipeline, but this is actually a very good foundation of how a pipeline should look like.